We'll give it a few more minutes here to get back to hopefully near the numbers we've had for the last couple of days, but welcome back everybody. We're live on YouTube, so welcome to anybody who is watching there as well. And a reminder to folks on YouTube, you can submit comments or questions through the YouTube chat if you have a Google account. If you don't, you're welcome to just email me directly. The info is there on the YouTube video. And we'll get moving here in just a minute or two as we collect a few more people. Okay, well, why don't we get started? We've got a pretty good number, about 50 people on the call now. So thanks again to everybody for coming back and joining day 3 of the Antarctic Subsea Cable Workshop. We're really appreciative of everybody who's coming and has contributed so far, and we also appreciate the support of the National Science Foundation for this workshop. I'll just remind everybody that throughout the day, we'll ask you to stay muted until Q&A sessions. If you do have questions, it's always most helpful to use the raise hand function, which is down in your Zoom controls at the bottom of the screen, or paste a question in the chat, and we can have some interaction there in the chat box, or try to get to those questions and ask them verbally once we have a Q&A. So today's objective is primarily to come together and present back from the breakout rooms that we had yesterday. So just remind everybody, and especially those on YouTube who weren't actively participating, yesterday we had 2 different sessions in breakout rooms across 5 themes, and we brainstormed across all of these themes. So I'll just read them out. So the first breakout room was about smart cables and ocean sciences. The second room was achieving connectivity to Antarctic research facilities. Third room was connectivity to advanced Earth, atmosphere, and space sciences. Room 4 was glaciology, biology, and other Antarctic research, and breakout room 5 was connectivity to advance education, engagement, community, and human well-being. So today we will quickly get through our welcome and all the goals for today, and then move into presentations, presenting back from those breakout rooms with hopefully more interaction across those rooms, and then moving towards identifying priorities, any gaps that we have in the workshop structure, and what we need for to fill those gaps moving forward. I want to remind everybody that we will have Lisa Troutman with us again, who's a graphic recording specialist. So she'll be doing this real-time graphic translation of our conversation in the first 2 hours of the workshop. And we'll be able to pin her screen once she arrives. I think she needs 5 more minutes here before she can join us. But that'll be fun to keep an eye on, and these will be great products to illustrate what we've been talking about on primarily day 1 and today of the workshop. She did join us yesterday for a great conversation we had with folks at South Pole Station. We've all seen these slides a number of times again, but I want to keep repeating that the objectives of the workshop here are to explore the impacts of having full digital connectivity to McMurdo Station in Antarctica, and then to also outline the use of a submarine cable, that cable connecting McMurdo to New Zealand as an instrument itself for scientific research. So we need to keep that in mind as we are having our discussions, and really stick to the science impacts as much as we can, and also getting as many hard numbers on data volumes and transfer speeds that are currently needed and will be needed in the future is a big priority as well. Again, we're working towards a short sort of executive summary style report for the National Science Foundation by early August, we hope, and then a full report by September. And please, if I've forgotten something, any of my co-organizers step in here, but we are going to be able to quickly get into the presentations here. I did just want to highlight the Jamboards, the Google Jamboards we used to sketch out some of what we talked about in breakout rooms yesterday, just to get a sense of what we did yesterday. I'll add the caveat that not all of the breakout rooms used the Jamboards equally, so no judgment to those who instead focused only on their Google Docs. All of the Google Docs that we had to take notes in are a wealth of information and look really great. But to illustrate what folks did, the first breakout room on smart cables and the oceans just had, looks like, some reference figures, which are great to see, the potential cable routes for a sense of where things are being considered at this point. Group 2, we'll give you guys a bit of a pass. It's a nice scribble at the bottom right. I don't know how to interpret that, but maybe Garrett can enlighten us later. Group 3, some good use of the sticky notes and a range of thoughts there. Group 4, group I moderated, we did some sketching of ideas on the biology and glaciology side of things. Looks like we like maps. And group 5, wow. Excellent use of Post-it notes and color to line up these different topics in your breakout groups. So a really cool range of uses of the breakout group or the Jamboards in breakout groups yesterday. And so this is where we put our heads together yesterday and what we're bringing out today to share with each other, and move towards identifying what all we've covered here at the workshop, so that we know what more work we have to do moving forward to drafting reports. And with that in mind, I think we're basically ready to start summary presentations, unless there's anything that I've missed. So I'll stop speaking briefly if any co-organizers, if I've forgotten anything. Otherwise, we'll go through the breakout groups by room number, and each presentation we gave the instructions yesterday. You should have about 10 minutes prepared. It's okay if it's a little bit less. Maybe try not to go over 10 minutes for your presentation, so that we have 10 minutes after each presentation to discuss and have a question and answer session before moving on to the next session. And then we'll see where that gets us. So we have 2 hours set aside for this. And if we have time at the end, certainly for more open discussion of all of the breakout rooms, that'll be great. Or there's a chance we might move on with our agenda and get on to the other things that we do have scheduled. I guess I should remind us that after this, a primary discussion that we have is a discussion about those priorities, gaps, and things we may have missed after the presentations. And then after the very last thing here at 4:15, we're going to have a sort of circle back with the National Science Foundation representatives, so that we can hear from them or ask more questions of them with an eye towards priorities, gaps, what we need to do a little bit more work on. Okay, so I will stop speaking there, and we'll go back to what we're doing right now, summary presentations. And it does look like Lisa's joined us, so we should have her screen pinned up as we're going over these report backs, so that you can see her graphic coverage of what we're talking about in real time.
If I can just add one comment, Peter. We got, so during the Q&A after, We certainly invite people within the breakout groups to add anything that may have been missed, but we especially want to use some of that time for people who were not in each breakout group to be able to ask questions and ask clarifications of what was going on in the other rooms because you were too busy in whatever room you were in. One of our survey responses yesterday sort of bemoaned the fact that there wasn't enough time to really roam between groups and find out what was going on everywhere else. So this next 2-hour period is really the time for anybody to probe much more deeply into anything that was going on in the other rooms, both adding insights and asking questions. Thanks.
Yeah, thanks, David. That's a really important clarification, and I'm looking forward to that part of this session as well. So I will stop sharing my screen right now, but I am happy to share the presentations in advanced slides if folks would like. So
yeah, why don't you do it for the first one, Peter?
Sounds good. Okay.
I'll just interrupt to our friends who are following along on YouTube. Please add your questions, and we are monitoring those, so can bring those into discussion. So please make sure to flag any questions throughout these presentations, and we will do our best to get to them.
Okay, I will find group 1. Okay.
Perfect. Okay. You can move forward here and go again. You've seen that. Go again.
Oops.
And up there.
Oh, okay.
So in the description of the session, we had these topics, and we added this last one. How would cable measurements in the ocean add value to real-time climate change observations on the ice? So linking the land measurements to the ocean more explicitly. Next. So these are, I have one slide for each of these topics, and hopefully I'll get through in 10 minutes, plus a final conclusion. Next. And I do want to thank all the contributors. Some people will recognize very explicitly cut and paste here. And here, in the first one here, Southern Ocean and Antarctic circumpolar current. The current is the Earth's strongest, ocean's strongest current, connecting most of the oceans, shown on the right. And the variability is very important for climate change. And that this impacts the entire world in marine environments everywhere. And the Southern Ocean is a sink for heat and CO2. And then to compound the problem, though, is it's the least observed ocean on Earth. So with measurements on a cable, specifically ocean bottom pressure at various steps along the topography, we can directly measure transports of this current. And this can inform us about the entire current around Antarctica, because the horizontal modal structure is relatively simple, and mode 1 carries much of the variance. So this, by monitoring this choke point between Antarctica and New Zealand, we can inform ourselves about the rest of the ocean. We do need Aussie's observing system simulation experiments as a precursor. Next. So going down deeper, so to speak, looking at the Antarctic bottom water, with cable measurements, well, first of all, the bottom water is the coldest, densest, most prolific water mass in the ocean, and spreads out throughout the world's oceans, down at the bottom. It's the densest water, and the Ross Sea is a dominant, one of the two dominant sources. And again, it sequesters heat and carbon, and that means it's heating up, and there's carbon dioxide being carried down deeper into the ocean. And again, it's fast warming. Down on the map on the right, you see red down near Antarctica, which means the deep ocean is warming up. And again, we have very, very, very few observations. Those black lines are ship measurements, nominally occurring every 10 years. So with a cable, we can sample without aliasing, with acceptable spatial resolution. we do want the vertical distribution on the slopes. Watching temperature change along the cable is absolutely a first order result, and we'll see the changes in temperature of that bottom water as it moves northward, and also the thickness of that layer. And then again, with pressure and pressure gradients, we can estimate bottom currents and choke point heat flux, heat transport along the bottom. Next. And then we can also look at how the melting ice creating fresh water affects the ocean and sea level, and how that distributes itself throughout the world's ocean. And there are various observations showing sea level is rising around the melt related signals, but it's difficult to separate the effects of adding this new mass of fresh water to the ocean, and separating that from other effects affecting density in the ocean. So obtaining estimates of heat transport across the continental slope is one of the goals here. And ocean bottom pressure observations can significantly contribute to the improvement of the GRACE satellite mission, which measures gravity and is an estimate of ocean bottom pressure as well. And these in situ measurements can help resolve land ocean ambiguities. So again, with sustained temporally unaliased ocean bottom pressure along the cable, we can help separate the effects of added mass and steric temperature basically changes. Next. So one of the things is to monitor the ice itself, and there are various ways of doing this, and sensors on the cable can help, and especially near shore. DAS, this is distributed acoustic sensing, a new technology using optical fibers, can be important for detecting the acoustic signature of ice changes and so on. And the plot on the right, well, the cartoon just shows movement of ice and icebergs and flow and so on. The one on the right shows spectra of ambient sound actually off Australia, just showing that ice noise absolutely shows up, and it turns out to be periodic over time, seasonally and so on. So the smart cable sensors, both seismic and acoustic sensors, will provide an unprecedented opportunity to monitor more aspects of the ice and interaction with the oceans. Next. In many of these aspects, ocean sound absolutely plays a role. Ocean sound is an essential ocean variable, so and that's been vetted by Goose basically. And one can divide this to passive acoustics, just monitoring ambient sound. The ice, as mentioned, marine mammals, it's essentially impossible to visually see marine mammals there. And acoustics is the only way, measuring seismic T phases and wind and so on. And here I just mentioned there are new roles for distributed acoustic sensing and optical fiber sensing. And in those communities, they're learning how to use those new techniques, and the sensitivity is going down now into what would normally call ocean pressure. So ocean waves and lower frequencies and so on. In the active areas, sources judiciously placed along the cable, as shown in the figure, could provide underwater GPS for future gliders, autonomous vehicles, and floats traversing the cable route and out to a very large area. And then and depending on how much ocean modeling goes in, that can be relatively precise. Also, with active acoustics, one can do thermometry and tomography, which again increases the footprint of spatial sampling, using man-made sources, using the ice itself as signal, a source signal and also repeat earthquakes. At the smaller scale, it'd be good to have a general purpose transducer that can provide ACOMs to surrounding autonomous instruments and pingers, inverted echo sounder and geodesy and so on. Let's see, next. In the area of global seismology, the sensors can significantly improve ray coverage. The oceans essentially have no seismometers in them, so anything we add will absolutely help. And then furthermore, the Southern Ocean is just simply poorly resolved with today's 3D seismic models. There's just not enough data. And the maps down below, basically much of the world is unresolved from the seismic point of view, but the Southern Ocean especially so. With some additional instrumentation, one can improve attenuation models and ultimately work up to the standards of the global seismic network stations. And again, fiber optic sensing within the cable can add sensitivity and so on, as well as the discrete smart sensors along the cable itself. And significantly here in Antarctica, such measurements can improve the imaging of the 3D seismic structure of the lithosphere and asthenosphere beneath Antarctica, allowing better quantification of elastic thickness. And this constitutes a major uncertainty in models of climate change, in which isostatic rebound of Antarctica plays a feedback for melting of the ice sheet. Next. In a regional, or actually sort of still aiming towards the globe, there are almost no observations to constrain the total plate strain budget, and adding measurements here will help in that respect. Better mapping the strain budgets across the Pacific Basin, and better estimates of hazards and so on. And so note the observational gaps in the maps. Let's see, next.
Bruce, you're out
Let's
about
see,
10
there's a
minutes,
movie
so
here. What, 10 minutes?
Yep.
Yeah,
So if you can
almost
wrap up
done.
in the next couple minutes. Great.
Yep. Can you play the movie? Bill Fry, are you on the line?
Yeah, I'm here. I can briefly talk to this if you like.
Yep.
I won't turn on my video to save you my bed here. The map on the top left is a forecast map based on what we might see from a tsunami, just purely based on using earthquake recordings as a proxy. That's going to be the current state for a lot of events we would have in the southern seas. The image on the right shows you what we could do if we had a cabled instrumentation showing you water waves recorded during the event. And as you can see, that's cycled through some higher and higher resolution nested grids, showing impacts on some coastlines. So before a cable or without a cable, we're looking at colored dots on a map. With a cable, we're looking at time domain simulations.
Great, good, thank you. And the note there that it was mentioned, I don't remember the reference, but tsunami did affect ice shelves breaking off. I think in 2011, a major ice shelf broke and so on. So that's affects Antarctica directly. Next. Next. Yeah, okay, 2 more slides, this one. So looking sort of more technical kind of things, this cable route shown is just a straw man, but a suggestion is move the northern part a little west into the center of that trough, so to speak. We do want as many pressure sensors on slopes, topographical slopes as possible, to get vertical resolution of currents from horizontal pressure gradients. And it was mentioned that we should consider possibly other inline sensor module options, and that's a technical aspect. And then it was also strongly suggested that there some branch units with mini observatories with robust low maintenance sensors, distributing a handful of these south of New Zealand, the mid-ocean ridge between McMurdo and the Antarctic Circle to look at land, ice, ocean, seafloor interaction. And with the power and flexibility and implicit communications for these mini observatories will enable these other aspects, and then very importantly, future-proofing the system to provide capability over the expected 25-year life to add things, acoustics, local arrays, looking at bottom boundary layer, and especially biogeochemical and ecosystem sensors, and adding to the infrastructure. Imagine AUVs running along the entire cable. Next. So in conclusion, we recognize extreme dearth of data in this region, in the ocean region, and do expect very significant contributions to the Earth system science with this real-time, high-frequency sampled long-term decades acquisition. And we're spanning this inter-ocean choke point with connections to all oceans, and we'll be able to get this transport of this extremely important Antarctic circumpolar current. And at the same time, we'll be doing seismic and acoustic sensing for ice, marine mammals, earthquakes, tsunamis, and so on. And all of this is enabled by the provision of cable power and communications. I think an important point that Bill raised was to consider the coupling matrix between land and water for the Earth system. Conceptually have that in mind. Some of the obvious gaps in our discussions, biogeochemistry, ecosystems, observing system simulation experiments, cyber infrastructure, and connections to the UN decade. And so finally, to address these diverse science goals and future-proof the cable, we suggest this hybrid approach with fiber sensing, relatively non-invasive and passive, then smart sensors in the repeaters, and then a small number of branching units for external sensors. That's it. Thanks again to all the contributors. You can see your impacts here, and I apologize if not including everyone's.
Thanks, Bruce. I think I'll stop sharing so that we can all see each other. And I think it's okay to go beyond the 10 minutes and 10 minutes that were allotted for this and get some good discussion. So I'll remind everybody here, you can raise your hand or put questions in the chat for Bruce or for anybody who is in that breakout session, and anybody watching the live stream on YouTube, you can submit questions and comments into the chat there, and Julia is watching that, and she will bring those questions over to the Zoom chat for us.
So it was all self-evident, clear.
Captured everything.
Yeah.
Actually, I have something to add from the discussion. This was kind of a sidebar discussion that we had, but one of the other topics we touched on was the opportunities for students and other investigators who are interested in data science, machine learning, and artificial intelligence to be able to access these very interesting new data sets for developing new algorithms. So I believe Eileen mentioned that in our breakout session, if you'd like to add more to that, but I just wanted to get that in there, that there may be a whole nother area of interest around this for individuals that are interested in developing new methods to both access and analyze this data.
Good.
Okay, so it looks like Eileen doesn't want to jump back in, so we have 3 hands raised. We'll go John first, then Zhongwen, then Alan.
John Orcutt. you mentioned that there aren't many broadband stations in the oceans right now. Actually, the NSF is supporting now about close to 90 broadband systems that are generally in the ocean. They spend about 2/3 of their 2/3 of the year in the oceans, and we've increased the lifetime to a bit over 2 years now. So there are about 90 of these things deployed around the oceans, and of course they're in clusters, generally arrays and so on. But we are collecting, as time goes on, more and more globally distributed observations of broadband. This will obviously enhance this substantially by providing power and communications over the year.
Right, thanks. I guess one comment though, the data exfiltration problem is still there, and the maintenance costs. But yeah.
No, actually, we are telemetering now with gliders, so that the data are available at that with a delay of about 20 minutes at most.
Okay, Zhangwen, go ahead with your question.
Thank you. So I think Bruce in the last slide maybe just mentioned this with one word, that in the fiber sensing part, there's something called integral. I think those actually is the important part of it is this new technologies beyond the distributed acoustic sensing. There is a method that's measuring the phase change of the entire cable, thousands of kilometers long, still putting sensors only on that, all measure the polarization that can sense vibration integrated along the entire cable. I think these are relatively low-cost instruments that can be added to the system and monitoring the entire cable, not just, for that's only near the two ends. This would be extremely important for anything that is related to hazard and the warning purpose, because you will be monitoring entire paths simultaneously everywhere.
Yeah, I agree. It absolutely is. I think, and this addresses a comment, a question in the chat window. I see that especially the integral measurements will depend on having other cables that can be sort of combined in a tomographic sense, since the integral measurements are integral, so you're getting one number along the entire cable, and so it's not really possible to without additional information to get distance along the cable, for instance, and so triangulating with other cables, and one mentions in the chat there of other cables, and if New Zealand goes ahead with the Chatham Island cable, that could be the start of a cable network in the Southern Ocean, and so on.
Go ahead, Alan.
Yeah, thanks so much for the presentation. I was wondering, I'm a glaciologist by training, and I have this analog in my mind of, we thought glaciers were really slow moving until we got a lot more GPS and remote sensing data, and we saw that they were moving a lot faster. And so if someone had said, give me a business case for why we need to look at these things with satellites, I don't think we could have done the same thing then as we can in hindsight. And I'm wondering in this presentation around, trying to understand the ocean better and laying the cable, are there particular science questions that were coming up in mind? Like, if we can lay this, then we can answer this question. Or is it more of the, we don't know what we don't know yet? And that's also a really big question. Like, this is exploratory, and we should be emphasizing that. And if my question didn't make sense, let me know.
I guess my initial reaction is we're in the middle there. But,
okay, that's fair.
Yeah. Others?
I would just say that I feel like that's true of a number of the discussions that we had, where there are some questions that we could identify where having observations from a smart cable would clearly make an impact, and then there's just a lot where we don't know, and a lot of us being trained to ration bandwidth so much that we're used to being starved of resolution and of duration of observations.
Peter, this is Pat. Could I ask a question?
There is, Doug has a hand raised before
Okay.
you, if you don't mind him sneaking in, and then
No, go ahead.
we'll get you in line. Doug Weens, go ahead.
Yeah, I was just going to respond to the comment from the glaciologist that I think there are ways that this cable, smart cable with sensors, hydrophones, seismographs, accelerometers could really help glaciology by recording lots of ice quakes, and particularly looking at, for example, the relationship between ice quakes at the Ross Ice Shelf front with tsunami waves, which would also be recorded by the pressure sensors along the cable. And the cable would go right along the, offshore from Victoria Land. And so I'm sure it would record a huge number of ice quakes from all of that, from that ice sheet.
Good. Yeah, thanks for that. Bill has his hand up, and then Pat, sorry.
Yeah, I was also going to answer the question of Alan. From my perspective, we're getting closer all the time in earthquake science to understanding the role of stresses in generating earthquakes, and to use that in a forecasting sort of sense. A big unknown we have is what happens as you're changing the crustal stresses from unloading the ice sheets. What happens to the earthquake cycle in the southern seas? And I think this is something that we started touching on, having both on the ice measurements and cabled, saying something about the South Seas and earthquakes that happen in the South Seas that we could address more a specific research question.
Thanks for that. Pat, go ahead with your question. I'm just conscious that we might not want to spend much more than 3 more minutes in this first breakout.
Okay, I don't want to take us off topic on the current discussion. So I've got a different topical question. So I'll leave it up to you as a moderator.
Hey, Bruce, it's Matt Jetchu. I was just thinking that the there's not, speaking of unknown unknowns, as the glaciologist was saying, and as famous person who died yesterday would say, that we don't really know much about the horizontal distribution or the spatial distribution of these ice quakes, or the ambient or the noise in the ocean, where it's coming from. I mean, there's a lot to be learned there, I think. You won't know until you get up,
right,
get some arrays and listen.
Yeah, and the entire cable or the sensors along the entire cable provide a long array, and then also localized arrays would be beneficial. Yes, right.
I'll just add a clarification too for the glaciologist who asked this question is Alan Pope, who's a program director at Polar Cyber Infrastructure at National Science Foundation, and one of the people who prompted this workshop. So he is a glaciologist by training, but is somebody who's very much involved in organizing the workshop. So there are some questions in the chat, but I'm tempted to move us on to a presentation from the second breakout group. What do other folks think?
I think Pat had a question. He was trying to not derail that particular subtopic. Is that right, Pat?
Yeah, it was just, this is like a blue sky thought, since it's supposed to be a blue sky workshop. Tossing out something that could, our little effort here actually be the genesis of a larger Southern Ocean observing system given the Australians' interest in cables to their own Antarctic stations, and there is this commercial initiative that's gearing up to at least study a cable between Tierra del Fuego and King George Island. You could have, if this whole thing moves along those trajectories, you could have a large portion of the Southern Ocean instrumented, and maybe this could be the catalyst for that. So I'll just toss that out for people to chew on.
That would be wonderful.
I think Alex has a question or comment, and that probably should be the last one before we move on.
Yeah, it's just a quick comment. I'd reiterate the importance of biogeochemistry monitoring as well along the cable where possible. And I know just one example, oxygen is an important deep water parameter as well. And I know these are more difficult to install and maintain, but even a few along the way would be would answer some big questions.
Absolutely.
Yeah, thank you for that. Well, why don't we move on to hearing back from the second breakout group now. And it looks like you're gonna share your own screen, which is great.
Except that I left myself muted. Fail. Okay.
There's always one.
Yeah, go figure. So thanks again for everybody that participated in group 2. We had a very robust discussion, and Peter, to your question about the Jamboard thing, yeah, the squiggly line was abstract art, and everybody absolutely focused on the Google Doc to put stuff together. What I've done is put together a bunch of kind of aggregated thoughts and distilled thoughts of the material that's in the Google Doc. The other folks in the session can feel free to ask what planet I was on when I put the slides together, or try to supplement it through the conversation. I think do this. What I wanted to start with was to talk a little bit about, and not dive into a bunch of the details, but talk a little bit about the need and the way we should look at framing a bunch of the questions. Even in through the Q&A from the first breakout session, a bunch of the stuff that we started talking about was, how do you provision infrastructure for not a 1 or 2 or 3 year time frame, but a 20, 25 plus year time frame, especially when you stick infrastructure in the water and it's not really convenient to go dive down hundreds or thousands of meters to go figure out how to adjust your infrastructure in the ground. It is all about trying to identify what we could do with some of the capabilities that this brings to bear. A couple of comments early on about the current behaviors by researchers as well as staff that are stationed in Antarctica. The current behavior is all around the scarcity of the resource. So think time slicing. We had to schedule the polies when they had to visit so they could get a good and clear connection to us. Time sharing and really managing the bandwidth resources to deal with congestion, delays. And again, it's all around scarce resource behavior. And not unlike what we saw, you roll the clock back, even 10 years in some of the Pacific Island nations, even in some of the more prosperous economies. If you go back to even the 80s, when a T1 was the thing to get if you wanted to be well connected. Nowadays, people would just scoff at you if you said, "Well, I have a T1 to my house." Well, big deal. That's not what we do. And then also the evolution of cloud-based services, and really global cloud-based services, as to how we do our business and what we do when we're on our home campuses. So when we're on our home institutions, or frankly, even at home today, the expectation is you don't have to have and carry all of your computing and your processing and your data collection stuff with you. You take advantage of the things that are available, and you really don't care where. From the standpoint of serving infrastructure, from the standpoint of resources, from the standpoint of computing for data reduction and also data analysis, we really are used to the current mindset of assuming everything is connected. When you go to your home campus at your home institution, you go to your lab, you don't try and wonder, well, when do I have to schedule my time slice on the mainframe connecting to my time slice on Google? I mean, nobody even thinks about that. That's like not even in the conversation these days. So it is about trying to understand how to think through the possibilities. And as I think Ellen and Pat both mentioned, the possibilities that we don't know about yet, that will really drive some of the demand on a going forward basis. And then a quick plug for the kind of the differential between the NRENs, or the National Research and Education backbones. This is really not an either or conversation in terms of looking at how NRENs transport communications or transport payloads between various locations. It's a matter of looking at both commercial infrastructure and then layering the NRENs on top of it in order to provide that really peaky, heavy payload, pallet of disk drives, communication and transport between various locations, and doing it in real time, so you don't have to wait for the next year's cycle to make the adjustments that you forgot to turn the knob when the observation was actually occurring. Digging down into some of the conversations, probably 3 or 4 major slides here. All around the conversations that talked about the different routes that were currently in discussion, and then possibly in discussion in terms of how we might look at the path. I think everybody's seen the prospective path that goes directly between McMurdo and New Zealand, but also looking at maybe piggybacking on some of the other commercial builds that are in the space. A lot of these builds are in the thinking about it and PowerPoint build or PowerPoint project capabilities for several years before they actually get funded. And then you have, in the best case, anywhere from 2 to 6 and sometimes 7 or 8 years to actually put the cable in the water, going through permitting and environmental assessments, the actual construction, the assembly of resources. So this is kind of a long time frame planning cycle, but we need to get into the cycle on the front end so that we can understand how we actually execute this. And then part of it, determining how to actually get from and make the transition from deep water to shallow water to land. There's a lot of technologies that are currently available related to horizontal boring that's steerable nowadays that folks even 10 or 15 years ago wouldn't have considered. They just kind of trench. Or if any of you saw some of the pictures from the 60s where they basically dynamite through coral reefs, horrendous pictures if you pull them up. But that's the way it was done back in the 50s and the 60s and the 70s. But nowadays there's a lot lighter touch on the environment as we move through those zones. And then considerations for ice and icebergs, trying to figure out the marine survey thing, and the kind of the continuing principle about sharing investments and resources that other folks have already made in the space. In particular, the conversation kind of turned a little bit to some of the New Zealand conversations around the work they've already done in terms of looking at the Scott-based redevelopment and some of the other ocean surveys that have already been done by both the New Zealanders and the Aussies in their immediate vicinities. We went and touched a little bit on the smart cable stuff as it intersects with the pure telecom side of the house, and it really is to make sure that we understand how the different types of instruments and instrumentation can be enabled on the cable platforms. There's the primary reason that you don't see a lot of smart cables in the water today, and this is my opinion, but I think it's pretty accurate based on a lot of folks that we've talked about. The smart cables introduce risk to the pure telecom nature of a lot of the cables, the commercial cables that are in the water now. And it is about trying to measure risk and value to the owners of the cable. So I think the opportunity we see here is if we see say an NSF or a NSF New Zealand, Australian kind of consortium coming together from an ownership point of view, that collection of owners values much more highly the potential contribution of the smart cable infrastructure in its value proposition conversation than a pure play telecom, or frankly, even a Google, Facebook, Microsoft, Amazon would place on their own owned cable systems as they put them into the water. And then the added complication of these things are designed for 25-year lifetimes, and many times will live past that lifetime. So you have to design and engineer for absolute robust reliability and, to the degree possible, hands-off maintenance as we go through the lifetime of the cable. We transitioned to some of the conversations around, okay, well, you get to McMurdo, then what do you do? Where you get to some landing point on the continent, and then what do you do? And the conversation shifted into some of the different modes of aggregating communication and aggregating comms so that we can make use of the very high capacity submarine assets connecting us to the rest of the world. And, you know, so satellite is absolutely in the conversation. Various types of wireless. There's a lot of existing wireless on the continent, but if there was, say, terabit class backhaul capability to connect to the rest of the world, you could relook at some of the opportunities around enhanced Wi-Fi, maybe some WiMAX, LTE, 5G, 5G-ish, 6G when it becomes more commonly available, millimeter wave, really giving you the ability to carry those high payloads, then concentrate them at a site and shove them across a very, very high capacity backbone. A little bit of concerns to make sure that we don't forget that we don't and cannot interfere with the science cases. There is a bunch of spectrum kind of caution and guidelines around where you put radio frequency spectrum, what type of spectrum, and how that interferes or potentially interferes with the science cases and the science instruments on the continent. And then, and again, with the ability of having high capacity real-time connection to the rest of the world, the potential that we could actually have commercial service, for example, commercial 5G service deployed with that backhaul infrastructure in place. Last slide for me, talking about some of the next steps. We talked a little bit about the marine survey that had to get done and how it would potentially interact with the construction and the design portion of the cable, as well as the rest of the infrastructure that needs to be associated with the cable, including the aggregation facilities on the continent. Looked at a couple of the impacts from the regulatory side. I think we'll have the benefit of being less regulated than if we were trying to do this in somebody's direct territorial waters, where there was high impact to other operations and other kinds of things that have interest in the space. The environmental assessment will be absolutely critical, again, as the nature of the science around, both on and around Antarctica, is pretty key to us. And then the ownership models. I think we have an opportunity here. There's quite a bit of discussion in this space about, you know, how NSF might proceed from an investment point of view. The fact that the ownership of the cable would be science-based or high-value based from a global science perspective, I think makes a huge difference. I mentioned it early on in terms of why some of the telecom and OTT operators have not really engaged in this space yet. And you know, and really looking at the next steps of a robust desktop assessment, and then trying to, as part of the work that we're doing now, make sure we can consider what kind of current needs we have to be able to support existing science on the continent. And then from a planning standpoint, you know, really figure out what the horizon needs to be and where we need to be to support the science, to support living and working in Antarctica, you know, a lot of us take for granted that we just go home, pop our phones open, and don't really see the stuff that's happening even behind our little portable devices. There's a bunch of stuff that depends on high capacity and real-time interaction behind all of the devices that we're used to working and living with. And then all of a sudden, you know, for the transporting to Antarctica, they have to live in kind of a different bubble environment. And you know, the isolation that the police talked about in yesterday's conversation was really interesting, and I think into hopefully to a large extent was also discussed in breakout group number 5. So with that, I'll punt to maybe the rest of the participants as well as the folks on the line today to ask any questions, or maybe tell us what we forgot to put in the conversation.
Looks like Alan Winery has a question.
I have more of an observation. So I was in group 2 for a while yesterday, and I decided that I'd probably be more useful being a resource person in one of the other groups. And so in group 3, we talked about how would you connect those facilities that are within a 300-kilometer radius of McMurdo? What if you wanted to go that next step? And we talked about it, and we faced the overland is hard. We're probably not going to do it that way. And we talked about having additional branching units in the cable. And now the chat discussion this morning has talked about or leaned towards the possibility of a second cable. What if the Australians end up in a few years bringing one from Melbourne or Adelaide or Hobart? When you do that, you will like to have a branching unit to branch between cables, because if you do interconnect, it's going to be offshore. And that raises all kinds of possibilities for redundancy in both the smart cable part and the communications part. And then you got to ask yourself, what about other numbers on the clock? What if something comes down from Chile and you start to see the specter of a circum-Antarctic cable system, which interconnects those cables and probably is of great use to smart cable people. So that's my comment.
And a Chile to New Zealand possibility too that's being discussed. So it's, yeah, in some of those maps, well, the map on the screen here, you know, the Southern Ocean is totally uncovered with cables too, for that matter. So it'd be a new domain from a telecom point of view, but probably as data centers shift southward in the Southern Hemisphere, that might motivate more of these also.
Pat,
No, Grant, that's an important question. You want to share your response with the group about the risk making the cable smart? I know you answered it in the chat, but it might be good to tell everybody.
With me or Garrett?
Oh, to Garrett.
So really quickly on that, you know, a bunch of it is about how historically the telecom operators designed their stuff for single use, super robust, and literally armor plated, right? So that nobody can deal with it for 20, 30, 40, 50 years. So the resistance has been, the historical resistance has been, the risk that's involved introduces additional power use into the cable. So power budget over several thousand miles of a cable system, as well as how do you handle failures? So in general, failures are hard. So the redundancy that's built into the regular telecom backbone operations tries to tolerate failures to the degree possible based on the engineering and design of the units that go into the water. And then in the worst case, you go in, you pull the cable up from the bottom, you have to open it up, put it back, fix it, and then put it back together. So I think there's been a lot of progress in the engineering side. And we have some smart cables in the water now, as well as trying to, I think in our case, we've got one actually off Oahu, the Aloha Observatory, where we repurposed an existing cable that went out of service. But the whole idea would be to have a very robust engineering discussion with the cable builders and the folks that actually build the cable, as well as the repeaters and the branching units, to figure out how we fit all the pieces together. And again, here's the thing that changes with the nature of the ownership, because the ownership won't be a traditional telecom, or it won't be a traditional, it won't be necessarily like a Google or a Facebook. We'll take their money, but we don't want to take their operating principles. You know, if it's owned by and really run by people that highly value science and the need for the asset in the water, then I think it changes some of the risk conversations. And then we have to, again, we have to look to engineer robustness in the sensor arrays, or robustness and resilience in the sensor arrays, so that it does not impact the transport mission of the cable.
So let me toss in. Alcatel has publicly stated they will provide smart repeater capability and guarantee that with their usual 25-year lifetime warranty. And then Subcom, as not publicly, but I mean it's known that they powered branch unit to support auxiliary anything, you know, widget X. And that would be telecom certified. And then the examples of existing system, Garrett mentioned one I run, you know, it's been operating 12 years now, using 30-year-old cable. So it's very reliable. And then also the Japanese systems have a combination of, I mean, in their case, they're having sensors with enough communications to get data back in line, and so you know, they're in a position where they just need to add telecom back into their systems with optical amplifiers. So again, a lot of it's perception of risk, and you know, projects like this would perfect, and the Portuguese one I mentioned are perfect because governments are behind it and they're basically assuming risk.
Right, all good points, and you're right. The engineering has, you know, we're passing over those hurdles now with the engineering, and the manufacturers starting to step up, which is fantastic.
Yeah.
Yeah. Could I add something to that though? So actually, I wanted to back up a little bit on the regional question, but on this particular topic, my thoughts are based on kind of what I'm hearing through Bruce and some others about what the commercial cable industry thinks. I think for our purposes, there might be the need for the government to put a little R&D investment into this up front, especially for any inline sensors. You wouldn't want to be reliant on just say one cable supplier like ASN, Alcatel, for example. You'd want to have other options, I would think, when it comes to an investment of this size. And one way to guarantee that would be, I would think, that if the government were able to put upfront some R&D money to help the commercial sector retire some of its risk, they'd be more willing to entertain this and maybe help level the playing ground a little bit. Just a thought. Backtracking on the regional coverage question out to 300 kilometers, I happen to have on the other screen here at home a high-res map of the McMurdo area with some range markers on it. 350 kilometers is about out to where the other international stations are, Jangbogo and Mario Zucchelli, which could theoretically be serviced by a branch off of the main cable. It's about 250 kilometers from the notional cable run I picked to get over to where they are. Ice conditions permitting, because that's over near the Drygowski ice tongue. So I'm not sure what that would mean. Someone would have to look at it. But for the rest of the region, especially over in the dry valleys, which is an Antarctic specially managed area, it's where an intense area of our science research, which tends to be seasonal, and so only during the austral summer, and it can move around within the valleys. I think wireless would probably be an ideal solution for that, which is what we do nowadays. Not really very sophisticated, but targeted mountaintop repeaters, long-haul microwave relays, use of advanced 5G, LTE projected down into valleys. I think we could really connect the last mile problem And that's all more conventional engineering, I think. I don't think there are any major technological breakthroughs needed. It's just doing sound engineering practices and good design.
Thanks, Pat. I just want to flag for timekeeping here that we're headed towards taking a half an hour for each of the breakout groups, which is going to put us long in this session. And I want to make sure that each of the breakout summaries gets equal treatment for sure. So just flag that. These are excellent discussion, and Matt, you should go ahead and ask your question, but we're going to have to go long into the break and potentially into our next session, so everybody's aware.
This is just a quick comment. It fits in with something we talked about before we actually get to the next breakout group, number 3. I'm glad you mentioned sensitivity about Wi-Fi or 5G. 5G just lost a battle in the weather community because it's going to interfere with things that we want to observe. And we lost that battle with FCC, and that's a done deal now. And so I appreciate though being sensitive, because even though we lost that battle in meteorology, doesn't mean some other sciences are going to need some spectrum somewhere, because we're running out of spectrum, right? We're all on top of each other at this point. And so I'm thrilled you mentioned it, and I appreciate that being noted somewhere for the group to be aware of it. So thank you kindly. Great presentation.
I don't know if you noticed it, Matt, but I did put in the chat that I actually have some support from the National Telecommunications Information Administration Institute of Telecommunications Science to kind of look into that very topic in and around McMurdo.
Okay.
So if you want to volunteer to be consulted by them, let me know.
Yeah, Jordan Gerst, the guy at NOAA who spent a lot of time on this issue. He was at Wisconsin for a while before he went to NOAA, and like I said, with the ruling that's come down, where that part of the microwave spectrum, and I'm not a microwave guy, it's going to be a big smear in big parts of the planet where we use it, and there'll be no signal for us to look. So I don't know if that will gain us anything over Antarctica, because I don't know if we can do that sensing over ice or not. I'd have to investigate. So thanks. I appreciate the offer, Pat. I'm glad you have money.
I didn't say that.
Well, it's a study that's got to get done. So thank you.
Great. Thanks for that. And thanks for all the questions and comments. There are a few more in chat, but I think we should move on to hearing back from breakout number 3. So I will share slides for that, and I'll let you guys figure out who's presenting.
I'll present for this group. So we were breakout group 3. We were a relatively small group, especially for the first session, but then much larger numbers for the second. I want to thank Jesse Baker from PGC for note taking and helping coalesce the summary slides, and also Matthew Lazara and Chloe, who are both on, who I know added to these. I'm going to do my best job. Our group focused more on text summaries than we did on visuals, but I'm going to walk through these, and I would certainly like any and all members in the group to speak up and over me if I'm missing important points. So with that, I'll start going through them. So next slide, please, Peter. Okay, so in terms of advancing the science, our group was looking at how will increased connectivity advance the study of geological processes underlying the ice sheets, physical and chemical changes in Antarctic atmosphere, and the use of Antarctica as a platform for studying astrophysics and astronomy. So especially the data intensive experiments at the South Pole Station, which we had the benefit of connecting directly with yesterday. Next slide, please. Okay, for focusing on geological processes underlying the ice sheets. So the opportunities this could enable are expanded collaboration. It would increase access to fieldwork and enable more remote collaboration. Researchers would not necessarily have to go to the field in order to participate. This would allow students and postdocs to take a lead on fieldwork, for example, but still have access to people in the US or other off-continent locations for guidance. Broaden science through new field data collection tools and techniques. Often researchers only leave instruments out during a short, perhaps 6-week field campaign. If field stations could collect or transmit data for a year or more, it would enable us to do more time domain geophysics. Temporal data is key to understanding geological dynamics under ice, and a cable would facilitate expanded temporal data collection to ask and answer more science questions. So, for example, for already existing long-term stations such as PoleNet, a cable could help get data from those stations to CONUS faster And we recognize that this would perhaps require connection, well, will require connection from field sites to McMurdo, which Pat and many others have touched on here. It could better help support fieldwork. Ground parties are very dependent on wind and local conditions. Anybody that's been to Antarctica knows this very well, and changing conditions can very rapidly alter plans for research. Matthew Lazara is on this, is one of the best weather experts in Antarctica, but getting weather forecast in the field to make decisions about field science could help us better plan the work to be done and be more efficient in the field. So again, it's important to consider the next step beyond just getting to McMurdo. Next slide, please. Okay, I'm going to let somebody else in the group speak to this figure. It's also on the next slide, so we'll discuss it there. Changes in the Antarctic atmosphere. So to put this in context, McMurdo receives satellite observations, data, and imagery used in science research and numerical modeling. Currently, hours go by before mid-latitude stations get data from some polar orbiting satellite observations over Antarctica. A direct link from McMurdo at the data volume that forecasters, researchers, and education want will need a lower latency, high volume connection. To make the models perform well, we simply have to have the data to do this. It can unlock real-time forecasting. A cable would be transformative for real-time data and meteorology. Low latency transfer of data from Antarctic satellite receivers to mid-latitudes would improve real-time forecasting models. A fiber cable would be the fastest way to get high resolution direct broadcast satellite imagery and data to researchers, forecasters, and educators. Next slide, please. And then Matthew, could I ask you to speak up? But
Sure.
I think you're the one that put this in there. Could you speak to this one, please?
I did. This is how we're trading data right now in the Antarctic meteorological community. We're using Unidata's funded project called Unidata built something called LDM. We built a version of it called the Antarctic IDD. So we're trading numerical model data, automatic weather station data, satellite composite imagery. Notice there's a little purple line here that goes to McMurdo. This is actually a future vision. Right now, Wisconsin connects direct to McMurdo through satellite, same as the Mac weather forecasters from Charleston. But in the future, you know, with a cable, this would be nice because then we could get not just snippets, sample, reduced data, but the full thing. And it would be able to get shared, included in the numerical models, ones that are run at NCAR, for example, here. Bird Polar Research at Ohio State University does the development. And then that data can get shared around and get to weather forecasters. And of course, good weather forecasts leads to good safety for all of us who are working there.
Thank you so much. Next slide, please, Peter. So Antarctica has a platform for astrophysics and astronomy. So for context, the South Pole is the ideal place on the planet for cosmic microwave background observation. It's high elevation, clear skies, and a star field that's continually visible. Particles and dark matter cannot be made in a lab, but they can be studied in Antarctica. This was really a big take-home message that I got yesterday. Data volume is large and growing, and likely by an order of magnitude. So in 10 years, instruments at the South Pole Station will produce more data than the Large Hadron Collider. Again, touching on latency limits, it limits what can currently be done with the data. Sensor calibration and quality control checks can't happen in real time. So in quotes, if we have in quotes, these are some of the comments during the breakout. If there's a calibration issue and you don't see it until a year later, for example, you lose a whole year of data. Live analysis of incoming data is limited, and external communication, as is external communication of real-time events. With astronomical transients, time-sensitive celestial occurrences, there's a time value to alert others in the astronomy community to observe these phenomena. The current lack of continuity of internet connection and high latency are issues that limit the science. That science disappears if hours to minutes latency isn't there. Next slide, please. Okay, logistical hurdles of science without a cable. Data loss, this is something that our group touched on heavily, and then we've heard in other presentations. Oftentimes groups are transferring data by person via hard drives brought back to the States. And there have been instances of lost or corrupted drives coming back that result in losses of field data. So one participant mentioned in 2016, they lost a half a season of melt data because we couldn't process the data in the field. I know many of you on the workshop are scientists, and that's just simply heartbreaking and devastating when you have that kind of loss of data that you just cannot replace. Supporting operations, two-way real-time transfer of data would help field teams, especially with regards to weather, maps, real-time images of field sites. Having someone remote with access to field data as it's being collected would enable much better use of data to support science. So again, really just touching on that it's not simply just getting data to Antarctica, it's also getting it off continent to the groups that need to look at it often in real time. Next slide, please. I know there's a group specifically that focused more on some of the diversity and equity and inclusion activities, but we've been encouraged to look at this broadly across all groups. This is, again, something that came up during many conversations, but equity is an important issue. And in terms of transformation, a cable could certainly level the playing field. There's connectivity inequality for who has access to Wi-Fi. Scientists may have access, but support staff may not. Access to the internet would be available for all support staff and not limited to just scientific work. Next slide, please. Okay, how can better connectivity shift field team leadership towards the benefit of early career scientists? A postdoc had mentioned they were interested in the workshop to learn about how their potential future research could benefit from a cable. The science that is possible for early career researchers will broaden if there's a cable to facilitate new data collection and collaboration paradigms on ice. Real-time communication would be possible via fiber cable connection. Students and postdocs can lead field teams while maintaining support and guidance from mid and late career researchers remotely. And these kinds of advances mean that early career scientists would be able to expand the science during their career. Next slide, please. How could it influence recruitment efforts, particularly for historically excluded groups? It's noted that fieldwork proposals, understandably, is a huge challenge. With a cable, we reduce the footprint on ice while facilitating more access to field projects. It could broaden access to field work and increase equity and access to U.S. Antarctic Program resources. And I've heard this from others as well, but it came up during our group. The feeling of being McMurdo for the first time feels a bit like being the new kid at school. Having cable connectivity could help build a community of people off ice. So more interaction with field teams there could help get people ready for life on the ice from both a science and social perspective. So ultimately, there was a feeling that you could get more done if you became more familiar with the culture, the vocabulary of the environment before you deployed. Next slide, please. I've got two more to go here, Peter. I'll try to be quick. So for early career plans and mentoring, it would connect off-continent members. Timer here. Of a research team to provide real-time support through efforts including data validation and triage, reviewing field data offsite while the team is still there and deployed, and able to make changes to collection protocols, sensor calibration, can improve fieldwork and build more inclusive research team. So again, the two-way communication is really important. So not only getting data collected there, but getting it off continent so groups can help make real-time decisions that could better shape and transform the science. Next slide, please. So this is building on that, stronger collaborations in continent, stronger collaborations off continent. For PGC, there's a participant that mentioned having a direct connection to that data would make the science more efficient. Two-way data volume, again, we've touched on this, is extremely important. And for a long-term monitoring program at something like 15-second timescales, having remote access to that data in real time can enable changes to the sampling plan on the ground. Having someone remote with access to that data would enable much better use of the data to support science. And then last slide. How can it enrich teaching back in the US? Again, it could provide direct access to science that is happening at McMurdo from anywhere. So for example, this may make it possible to teach a class from McMurdo and run special classes with a focus on McMurdo and Antarctica. And I know educators and other had mentioned when somebody asked directly about the pad, if it would reduce the constraints on YouTube or other means. Julie, I think, had said that educators all over just jump for joy. So you can't underestimate or just the value of having some of these connections with science and groups that are in Antarctica. And we saw that with our connection to the pole yesterday. So thank you for everyone for contributions. And if I missed anything, by all means, please speak up, and we're happy to take any questions or discussion from the group.
Thanks, Jonathan. So if anybody does have questions, you can raise your hand or put them in the chat box. There've been a lot of good questions going by in the chat. I'm sorry to the folks on YouTube. It's hard to always share those. I just ask, maybe, if we do see good ones go by, maybe my fellow organizers can help bring good questions and answers in the chat out so that we can verbalize them for everybody watching the live stream.
I'm seeing one question. This is from Pat Smith in the chat window. So to our group, did anyone talk about linkages to the popular media like TV, which thrives on real-time, high-quality video, to extend the reach of public awareness about Antarctica and its relevance?
No, we didn't, did we?
Actually, Jonathan, though, we had a real-time demo of how exciting that was by being able to talk to the folks, the polies, and also learn about their very popular TikTok channel. So in terms of just, getting folks connected to scientists on, in these remote areas, I think it's just of huge value in terms of promoting not only science to the public, but also NSF's mission to really connect science to the public. So I think that's a big deal. And it was super fun talking to them too. One of the highlights of this workshop, I thought.
We'll touch on this in the next breakout group as well, sort of from the field science perspective. And I know that the last breakout group probably discussed this at length as well. And I guess I might add that, to a lot of the points that Jonathan and the third breakout group brought up about how greater connectivity can empower early career researchers and more diverse researchers. I feel like there are also a lot of complexities to that and that we discussed in our group of sort of dividing attention can be tricky when you're deployed to McMurdo, or especially in the deep field, and you're sort of so mission focused and have so little time to get your work done that it can be hard if there are added distractions or added expectations that are external to the field party, and they're very tricky and important dynamics to a field party that having external parties help manage the science there can be really fraught somewhat already. And in our remote connections are usually through Iridium. So there are tricky issues, and there are clear advances and other slight hurdles with some of the added connectivity. Yeah, go ahead, Matt.
Sorry, I couldn't find my unmute button. I'm gonna be a little bit of a Debbie Downer here, but I appreciate the idea that a subsea cable will help, and increased connectivity will help with data loss. But your hard drive corrupting on the way back to the States is a data backup strategy failure, not a connectivity failure necessarily. And we still need to have strong strategies for data backup, even with a subsea cable. And so this is not a panacea. It's not going to solve all of our problems in terms of, oh, now we'll always get our data and we'll have no failures. I think we can have high throughput of data right now and have safe backups of data without a subsea cable.
I'm just going to follow up a little bit on that comment. So that's something that we did discuss, that this wasn't, replacing our current methods of removing or transferring data, on person. But this is just another layer to our data storage and data accessibility strategy. So we did talk about that. I just wanted to point that out.
Thanks for bringing that up. It's going to say not all grantees have got the ability to pipe data off continent. I'm fortunate that I'm allowed. Thank you, Pat. Much appreciated. But not every grantee has that capability. When they pull their stuff off the field, they can't easily pipe back oodles of data, at least at the volumes I was listening to, with ease without getting noticed or having a limitation. This obviously would get rid of that. But it doesn't mean you're right. That doesn't mean there shouldn't be other data strategies thought of. Like if I know I have in McMurdo what I need, okay, what can we do to make sure that that does get, properly managed so it doesn't get wrecked on the way home?
I think we certainly can take time for one more question if there is one, although I'll note that the following breakout group is somewhat similar to this first one, so we could continue and catch extra questions after breakout group 4 reports back. So if there are, let's see, well, Pat has one for group 3. So if a high-speed data transfer point were made available at McMurdo, then a field team could do a data transfer to a example cloud storage as the primary means to move data.
Exactly. You're right, Pat. It's what exactly we wouldn't that be nice, right? And it takes care of another piece of inequity, by the way, right? For those grantees who don't have that built into their SIP or would be approved to pipe off the amount of data that they've collected out there, that would be no longer an issue.
Well, I think for time and let's see, we get more comments as soon as I'm trying to move on each time. There's a comment from Eli Dart on YouTube. I find the case for rapid turnaround of analysis to be compelling. If you need to make a change and can't tell without data analysis, you need to be able to get the analysis done. And I think that is, a component of a lot of our field research as well, that is useful to be able to send, to more quickly analyze your data, either yourself in the field with some additional computing power if it's needed, or if you can quickly send it off continent back to somebody in the States who can take a look at your data and tell you how to move forward. That's something that I personally have done already through Iridium, being able to send short messages of diagnostics at the end of each day. And actually for the time zones in the US, it works perfectly to have somebody check your numbers while you're sleeping. And then when you wake up, you have had a clear head to look at numbers on how an instrument's operating.
Yeah, it's a two-way street, absolutely. And if we're talking really large data volumes, that becomes more relevant to what we're discussing here. Absolutely.
Peter, I have a question.
Go ahead, we'll take that'll be the last one.
Yeah, not to start a whole new conversation, but I'm curious, what is the cyber infrastructure support for scientists at the station? Does each research team have their own IT folks that come along with them, or are there a group of cyber infrastructure professionals at McMurdo Station that can help any scientist? Because as we remember, infrastructure includes people too. So just curious about that. What's the status of that?
I don't know if Dan Wegster's still on, or Pat, do you want to talk about that?
Yeah, that'd be great.
I'm sorry, I was typing in another email. Could you restate the question?
My question was, what is the level of cyber infrastructure support in terms of people at McMurdo Station and these places, in terms of being able to support the scientists? And do the teams have their own IT folks with them, or is there more integrated support? I'm just thinking this could solve a lot of these issues with data backups, transfers, corruption of drives, all those kinds of things. Just wondering what the support staff is like and whether that's something to think about.
The person I'm most familiar with for specifically science support is Carrie Pison, who works in Carreri Lab. They have a small IT team there that can take care of things like corrupted hard drives, support for laptops. They also support the mission links that are on the Traverse, which is a moderately cost solution, or a moderately costed solution for higher data rate systems. But it's a commercial service, so we have to buy, say, a 1, 2, or 5 gigabyte per month plan, and we're bringing together some details, some service plans that currently don't exist, but we're working with Iridium LLC to create an annual data plan where we can share across multiple mission links and such. So the mission link system, you can Google it. It's in use on ICE, has been now for 3 years. We've been using the vessel link for 4 years, and
Dan, you need to explain what that is. It's using the Iridium satellite system.
Right. The Iridium constellation, the satellite constellation, was replaced recently, and the satellites now have a new service called Certus, which is a higher data rate service than the legacy Iridium systems. So legacy systems were limited to very low data rates. The Certus can get up to about 720 kilobytes per second. And the only catch there is we have to pay for these data plans, and they're use or lose. So I track every one of these systems on a daily basis to make sure we don't have a runaway user that's inadvertently updating their firmware on their cell phone or something. And if that happens, I throttle it or suspend the service so that we focus the use of that data to support science, not, life management or a personal device that inadvertently got added to that closed network.
Yeah, there's a few caveats I need to add to that. So right now, that's typically outboard the standard Iridium service we provide. We've got an unlimited use access through DoD for low bit rate Iridium, which makes it very ubiquitous for people to use. The type of stuff that Dan's talking about, it's pay by the drink, and it's not widely used because it's basically a cost issue. There's nothing that prevents a grantee from putting this into their grant themselves and bringing in their own gear. However, the size of most grants, you grantees know this better than I do, but that puts a lot of pressure on your grant. Whether or not you could afford it or not, that's another issue. So there's kind of issues around that space. But I wanted to get back to the original question, I think, was about local support. Which is the thing that folks have to keep in mind is that we're very manpower constrained on the stations, especially at a small station like Pole, but also at McMurdo for IT personnel. They're mainly there trying to keep the core infrastructure going. They can do some walk-up support services like Dan outlined, but it's fairly modest. If there's anything that's aggressive that people need, it's probably going to be on their skills or their time available to support. So the more that the grantee can just kind of take care of their own needs, it's all under their control. I would think it would work out better.
Yeah, in the last 20-25 years being involved in the program, Glenn, I've watched the IT support that grantees receive basically decline. At one time, it was support where NSF contract folks literally wanted control and management all the way up to the operating system of my computer and had the staff to do it. And now they don't do any of that. I do that. So grantees do everything. However, if you look at the entire U.S. Antarctic program and back up, some places do provide their own support, like MacWeather. They have an IT guy that stays out, that provides support for them. Ice Cube, they're huge. They do their own. I think there's some comments in the chat about that. So it's unfortunately a mixed patchwork of how we all approach it.
Yeah, I was just thinking, thank you for that. I was just thinking another reason to have real-time connectivity, because maybe your IT person isn't at the South Pole, but you need to talk to them in real time to troubleshoot your systems. Just wanted to put that in there.
Oh yeah, absolutely. Be huge.
Right. The key point here for me is if you're bringing something that you may possibly need support from a McMurdo person, a GHG or an ASC person, put that in your SIP so we know it's coming. That way we can evaluate how much support we might need to provide and schedule people appropriately.
Great. Well, thanks for these questions and the discussion here. We do have to keep moving for time, so I'm going to present for the fourth breakout group. And I just am wanting to make sure that all 5 of the groups get time that they deserve here, and that we don't push too far into the one short break that we have. So I was the moderator for the fourth breakout group on, I guess it was mostly glaciology and biology, and the way we sort of unified that in our discussion was that we, the sort of 6 of us that were there are all doing field research off station, and so we all should have that shared problem of the last mile or the last 1,500 miles, as is the case where we operate. So please, any of my collaborators on this in the breakout, please hop in at any point if I'm not doing your part justice. So I thought it was interesting that the 2 parts that we really focus on, that a lot of our research focuses on, was the 2 top strategic priorities that were identified by the 2015 National Academies report. So the first one being the Changing Antarctic Ice Sheets Initiative, answering that question as soon as possible: how much sea level rise is going to come from Antarctica, how fast? And so on that subject, this is a typically complex diagram showing all of the ocean processes, atmospheric processes that are pushing around the ice sheet. Thwaites Glacier in particular, which is the most worrisome glacier, most important glacier in Antarctica, happens to be where the U.S. Antarctic program traditionally operates, but at the very, very far end of that. And we need more observations at every single point on this diagram and at every time resolution, essentially going back hundreds of years with ice cores with my work, and moving forward, having observations at any of these places at high resolution is really needed and could be enabled by not only having better connectivity, but instrumented cables. Not necessarily in the case of getting an instrumented cable thousands of miles out to Thwaites Glacier, but we have closer analogs to in the McMurdo region that are of interest. I'm not going to do this part justice as much, so please, Renee, hop in if you need to. But the second strategic priority from the National Academy support is identifying how Antarctic biota evolve and adapt to the changing environment. And a lot of work with that in mind is done in the dry valleys, which are about 100 kilometers as the crow flies from McMurdo Station. So this was our little sketch. I guess we tend to like maps. And I'll share, I guess, the way that we unified our approach, as I mentioned, was that we are all doing field-based Antarctic research. So we had some good conversations about that. And on the glaciology side, just to give some numbers here, current data transfer, I guess they're the same on either side. We're acknowledge that we're probably not going to be the drivers of increased data needs at this point, but that's also because we've been trained to have that scarce resource behavior, as Garrett mentioned in his presentation. So there is a component of, we don't know exactly what we could do with more bandwidth, but we certainly also do know some things, and that's on the theme of having more and better observations in more places. It certainly would improve things for the many subdisciplines of glaciology and in the organisms and ecosystems space. So just some highlights from our conversation. So starting with glaciology, I've highlighted in the box there the regions of greatest concern for us on the ice dynamic side of things, which the ocean looms large in how we're losing mass from the West Antarctic ice sheet currently. Unfortunately, those regions of greatest concern are more than 2,500 kilometers from McMurdo, so that problem of extending fiber or some sort of connectivity into the deep field, at least to our logistical hubs out there, places like Waste Divide, is an interesting challenge. All of our glaciology work would benefit, and certainly out in West Antarctica would benefit from better weather forecasting that would be enabled by greater connectivity. And that could also make the downtime that we tend to experience trying to get out to West Antarctica, hanging out in McMurdo, we could get a lot more of our job functions done while we're waiting. On the biology side, so Renee Brown was one of our representatives from the McMurdo Dry Valleys LTER. They are much more proximal to McMurdo, so potentially an interesting region for thinking about regional cabled arrays, plugging into a hub and extending a cable up onto the land to observe some of the ecosystem processes in the dry valleys. Understanding physical processes and cycles year round was something that came up. So currently observations in the wintertime are very limited. On the glaciology side, if we think more locally as well, the idea of regional cable arrays is intriguing to better understand fluxes of currents into underneath and flowing out of the Ross Ice Shelf and the Ross Polynya. We also discussed the idea of traversing cables on the surface of the Ross Ice Shelf to access holes that are currently being drilled by New Zealanders and US projects. That would allow for instrumentation of the ice shelf itself and then reaching down into the subshelf and potentially getting close to the grounding line of the ice sheet, where the ice sheet goes afloat and becomes the Ross Ice Shelf. Getting observations there with fiber smart type cables certainly would expand knowledge greatly. Let's see, some of this stuff was added here in the last few hours, so I haven't seen all of it before, but getting real-time feedback on data-rich experiments again came up, and that certainly applies on the glaciology side as well. Having that external feedback can be useful. It reduces the need for spending time while you're in the field figuring out what happened in your experiments, and increases efficiency while you're in the field. A little bit more of our thoughts on laying cables over on the surface of the ice. We've discussed this in various places, but that question of how to connect South Pole to the McMurdo fiber connection, that certainly having observations through a cable here could be really of interest glaciologically. And as Matt Siegfried brought up earlier, even thinking to trying to get that cable beneath the Ross Ice Shelf and come up where it needs to access the polar plateau near the grounding line of the ice sheet could be really transformative to have observations from a cable in that sort of location. And the last thing we talked about was that greater connectivity doesn't preclude the need for having people on the ground. So we'll always need people in the field to get done these complex sampling campaigns, and particularly where we simply need samples from Antarctica, and that the ability for them to respond to unexpected results or equipment failures, all of that stuff. It's hard to make it all remote, but certainly there are some efficiencies that you do gain by having external, better communications. We do have some concerns about that split attention with greater connectivity, although it does have clear advantages of troubleshooting with experts back in the US. And it's something that we already do with the basic iridium connections that we have. So we'll just end with that field parties have really unique perspectives and understanding of their own logistical needs. And so adding external parties to that on the decision-making side already causes inefficiencies, and certainly having more of that remote control could be challenging as well. So we address the benefits and some of the concerns. And I'll just remind that we have more information in the lightning talk slides, but I'll stop there, and please jump in any of the others that were in the group. Peter, go ahead.
Yeah, hi, Peter. Sorry, I missed the breakout groups yesterday, but was there discussion in your group about, and maybe you touched on this a bit in your slides, but if you're running cable on glaciers that are moving at different speeds, how you would deal with that? I mean, the strain is one thing, but if you got a fast glacier downstream of a slow glacier, you're going to just rip the cable apart. Did you have a discussion of that?
Not so much the technical aspects of how one would do that in maintaining a cable, but from a science perspective, I mean, that would provide all sorts of interesting information that glaciologists want. So I think, the engineers would be challenged by that, and the glaciologists would be pleased. Same as if we, brought a cable up through the ice. I mean, a cable like that is a perfect strain meter, but eventually, yeah, it will break.
Yeah.
Yeah, Peter, that was one of the reasons I suggested perhaps avoiding the surface of the Ross Ice Shelf in the first place and going under it. But as Peter Neff said, sorry, too many Peters going around. As Peter Neff said, those strain measurements, like we've never laid a fiber across a shear margin. And to be honest, shear margin processes are one of the biggest questions in glaciology right now. And so even if we got a month of data out of it before it broke, that would be huge. Now, obviously, there are communication things we need to balance here, but from a pure science perspective, you know, that's transformative science, easy.
And Matt, on the topic of strain, you know, Pat asked for the run up to the Transantarctic Mountains to the high plateau, can we better characterize the strain so that cable designers have something to chew on? I mean, I think we easily could have numbers on that.
Yeah, and so strain mapping from space is a thing we do, kind of hundreds of meters scale. We were just talking about this earlier, pushing that to higher resolution in a different workshop, pushing it to higher resolution for crevasse processes. But we can do that at a regional scale, down to a fairly local scale, and then, you know, put paths in there that minimize strain. That's totally doable right now with our current technology. If there are places of concern, we can go in with field experiments with, say, GPS or with fibers to actually test the strain environments.
So I mentioned this earlier, robotic control from the distance. So if you want strain measurements across a glacier, you know, and you know it's going to break, well, you want to be able to replace it easily. So you could have basically a rover, you know, that you know has a stash of cable reels, and it goes out every week and lays a new fiber, you know, and anyway, but something like that could be done remotely. You know, someone in the US could be controlling that, perhaps. So that's another possible application.
So I actually have
one other thing. I mean, as I think I mentioned in our group, their AUVs is actually about 20 years ago have laid fiber under the ice in the Arctic, over 200 kilometers. So having AUVs do things under the ice similar to that is tractable, although, you know, expensive, of course.
Yeah, go ahead, Matt, if you wanted to add to that.
Yeah, so the idea of like stashed AUVs, robotic ground vehicles was something that we brought up in our breakout group, because those are useful for science too. Like, you get a weird measurement. Okay, let's send our drone out and take some more measurements, take some visual imagery, some infrared imagery, whatever. That too, it would be an incredible capability, both in the dry valleys, on the ice sheet, wherever. And I actually have a proposal in review right now about autonomous vehicles laying fiber in Antarctica. So like, those are definitely technologies we need to be developing and be ahead of the curve on.
Let me just add one more comment and thought that I've had. You know, one of our greatest challenges in Antarctic glaciology is understanding what's going on at Thwaites Glacier, which is in possibly, you know, the one location that's furthest from any research stations and has the foulest of weather. And it's a place where we need observations of all kinds, including ocean observations that could come from a cable. But obviously, we're stepping down now from the challenge of getting a cable to Antarctica, where there's very little, you know, not a population, not a business case for doing that. And then again, you know, where we might want a cable is where we have absolutely no people and a very complex, you know, ice ocean atmosphere system that we want to have better observations on. So I don't think there's an easy answer to that, but that's sort of a fundamental challenge we have, is that some of the things that we really need to study are in the worst possible geographic situation. So I don't, I'm not asking for a cable to extend to Thwaites Glacier, but on the thought of having a cable, you know, crossing the Pacific from Chile to New Zealand or things like that, I mean, this is a major wild card in our understanding of future sea level rise, and it happens to be in a spot that's really hard to observe. So I think it's also important to consider, you know, the cable route, presumably through the Ross Sea, if there are processes that are captured on the ocean side there that do relate more broadly to circumpolar deep water that's affecting Thwaites Glacier, to those places where we just know we can't get a cable set up in our lifetimes. Maybe I'm being too pessimistic, but yeah, that's just an interesting challenge we have. So I want to make sure to take no more than another minute here for our session, so that we get to the 5th breakout room.
Peter, you're young. We'll make it in your lifetime.
Perfect. I'll take it. Okay, why don't we shift to the last but not least breakout group so that we have time. We're going to take a break at 3:10 unless the discussion does go long. So Heidi and Kristen, you ready?
Yep, we're ready. If you could pull up the slides, that would be helpful.
Okay. I'm sorry, just give me 1 second. Okay.
Awesome. Thank you so much. And I aspire to get us on break because I know my head is swimming and I'm learning a lot. And so this is really valuable. And I think some of the previous discussion has touched on some of what we collated in the breakout 5, which was focused on education, engagement, and community and human well-being. So I think the sort of broad key take home is that, yes, absolutely, increasing internet connectivity to the continent has the ability to transform all facets of what it means to connect with, communicate about, increase participation of the public in Antarctic research, as well as enhance sort of well-being on the continent. But that doesn't come without some, I think what we sort of landed on was some really critical thought and research in the years leading up to the potential connection being made to the continent. So I think the overarching, Peter, next slide, please. Thing that we sort of landed on at the end and sort of guided our discussion was this idea that, of course, Antarctica is connected to people, to communities, broadly, generically to the quote unquote public, and the opportunities to deepen knowledge and deepen this connection are, of course, infinite, right? And the main connection to communities being that of sea level rise to coastal communities. But we had some really wonderful lived experiences and expertise in our breakout session talking about the real imperative to use an opportunity like this to really deepen knowledge and deepen that connection. And so really envisioning this cable as of course, sort of this tether that goes both directions. So not only something that provides people on the continent a mechanism for getting information and connection and news off, but for really sort of building this tether to the rest of the world around the importance of the work that is happening and the research, the knowledge that are being generated about and on the Antarctic continent. Next slide, please. So in our breakout rooms, we discussed sort of 4 interrelated themes. The first, sort of human well-being, touching on implications related to culture, collaboration, community function. We talked at length about formal and informal education. So things related to connectivity for teachers and students, classroom education, mass open online courses, and ways to have real-time access, not only to people, but also to data and key learnings that are happening on the continent. We talked a lot around relationships to sort of connections to the public, so different methods and mechanisms for engaging different audiences and the opportunities that would be created or enhanced through this connectivity. And we focused at length on justice, equity, diversity, and inclusion, and some of the implications that this has for who gets to do research, who gets to have access to information, and really, to the best of our abilities, recognizing that we didn't have all the right people in the room to have this discussion, and that will sort of come at the end of the presentation, is really understanding the sort of implications and opportunities that this provides, should we approach it in a meaningful and thoughtful way. So I think the real emphasis for all of these 4 interrelated themes was this necessity to be proactive rather than reactive. So I think there's a lot we can learn in advance of a cable being connected that we don't yet know about how to really do this work, and this work spanning this broad cross section of disciplines, how to do it well and how to do it right. And so we have some suggestions for that sort of key take home that we hope will inspire the National Science Foundation. Next slide, please. So we've just sort of highlighted some bullets, since everyone has access to these presentations and documents, just to sort of get the conversation started for the key areas we focused on. So in terms of community interaction and function, of course, I think there's quite a bit that we could still learn about community interaction and function in Antarctica. But there are definitely both positive and negative implications of connections, both related to sort of culture as well as norms. So we talked a lot about the opportunity that this would have to reduce some of the existing sort of staff, sort of support staff to scientist divide that is, I think, unfortunate in the current moment, specifically related to internet connectivity. And then, of course, some of the things that surfaced through our conversation with the South Pole group related to concerns about how it might shift the culture if we have similar connectivity to that some of us have in our daily lives in other parts of the world and not currently in Antarctica. If that were to change, what would that mean for how people interact? And of course, it's surfaced in these conversations over the last several days around sort of the exotic, sort of special the nature of going to Antarctica and this opportunity, a rare opportunity to disconnect. Of course, I don't think that outweighs the benefits and opportunities that have already been discussed, but I think something that in thinking critically about sort of work norms and expectations would be important to consider. So this sort of bleeds into this next idea that we had, which is that sort of increasing demands on time. So what shifts if there is sort of unlimited or less limited connectivity back home? What does that mean for research and teaching faculty? What does that mean for folks who are on station but can be connected as far as potentially overburdened workload, and so therefore negative consequences on well-being? Would say university administration, knowing that you have access to the internet, still expect you to teach at the same time that you were conducting field work, which commands 150% of your bandwidth, your personal bandwidth. So just some concerns about thinking really critically about those norms and expectations moving forward. And this opens up important opportunities for social scientific research that could be started now in terms of looking at science of science, science of teams, remote communication, what innovation and community function. There are a broad range of scholars that look at this in other places. And I think this is a great opportunity to open up this area of research for Antarctic communities. So next slide, please. And we talked a bit about expanding Antarctic Research Community and the implications this might have. And I think the main take home here is that even if access, in this case, internet access is expanded, there are other structural barriers that need to be addressed that currently play a role in participation in the Antarctic research community and working on the Antarctic continent. And so, of course, the cable can't solve those things, but can certainly play a role in expanding access to research opportunities, to data streams, some of which we've already discussed, that would enable researchers and others to have access and near real-time access without having to visit the continent. So there's new teaching opportunities, new research opportunities that, of course, emerge from there. Of course, there's barriers that are reduced, both for those who are unable to access the continent due to disabilities or health-related concerns that prevent the travel or access to the continent because of rules. And around health. And so we definitely see there being opportunities, but we need to engage in more conversations with those that are currently not part of the community and really understand their perspectives and how this could or wouldn't actually address some of the concerns we have related to access and equity. And so, of course, again, just another area of further work, and I think a charge for the planning committee to expand our circle and maybe conduct some focus groups and interviews. Next slide, please. And Kristen, feel free to chime in here if I'm missing any key topics from our group. So the next bucket of our sort of 4 was the expansion of opportunities for education, outreach, and communication, acknowledging that EOC is a term commonly used across polar communication. So we're sort of sticking with that terminology. But of course, there's significant opportunities for real-time or near-time communication, remote teaching opportunities, media engagement. And so we see that as being a real win for engaging the public in Antarctic research and the people and the work and the process that take place down there to generate critical knowledge for the broader planet. And of course, we've heard this before, and we've had some of these conversations with Pat around sort of just because you can do it doesn't mean you should. And so I think the point here is really, I think just because you can do it, I guess the imperative is that we do it as well as we can in terms of thinking about what types of training, time, staff, other expertise are really needed to ensure that if and when these connections are made, we have the right expertise, capacities, perspectives on hand, ready to really take advantage of this increased connectivity. And that then therefore requires we need increased mechanisms for supporting education, outreach, and communication in terms of managing that increased demand and the increased access. I think part of this Peter touched on is that we end up, for those of us who end up with responsibilities related to communicating information back home, developing educational content for classrooms. Typically, people are sent down, and rightly so, because there's not a lot of person space down there, but end up with multiple hats. And the education hat is often the thing that gets left to the sort of after the science. And so there are some sort of unequal burdens on individuals who are expected to be down there to perform science and engagement or education efforts. And so thinking thoughtfully about how this might provide an opportunity to be more efficient with some of that work, and also think about how this could shift some of our cultural norms and expectations for people who are on the continent with these multiple important and critical roles. And I think this is something that many of us have been pushing for a while, and this provides, I think, even more fodder for doing this, is really developing an understanding as the science and the sort of case for the cable is continuing to be made, thinking about, are we actually achieving our intended outcomes with our current efforts? So what is the impact and what's effective about what's currently being done, and how can that information inform how we prioritize work moving forward? And of course, we need to expand opportunities to connect with communities that are most impacted by our work. So one prime example of that, of course, is coastal communities. Next slide, please. And I've sort of highlighted this already, but I think the imperative here is that there are opportunities for research today that can really inform and underpin making this investment really transformative and impactful immediately for the sort of broad bucket of education, communication, sort of human well-being, all of these facets of the sort of human dimensions and communication dimensions of this. And so while we think about environmental impacts and cable locations and instrumentation, we also need to be making investments in understanding community function, efficacy of our work to date, where are there real opportunities and shortcomings and opportunities to learn from the work that's been done already in this space, and expanding it where there are gaps. So this then means we need to bring in appropriate scholars and practitioners to evaluate this work, to do this pre-research, the sort of proactive information gathering, to really think about how to really assess the sort of the innovation and transformation, the transformative opportunity, those sort of infinite opportunities. How do we really move strategically forward and understand that what this investment is going to lead towards sort of effective, strategic, high impact, high value connection back with a range of different audiences and end users. Next slide, please. And so the sort of main take home as I sort of started is that we really need kind of parallel investments being made in terms of not only thinking about how do we get this access and how does it transform some of the physical Earth and space sciences and other sciences, but really understanding and doing the research and advances to understand how this really is going to drive transformation and effective high impact engagement and education with Antarctic science. And so I think that is a good place to end the discussion. I am not tracking the chat, but I see lots of things coming in. And so myself and the other folks in the breakout room, let's tackle those collaboratively. I hope I represented at least some of what was a very rich discussion in these slides. So I think critically making that an access equals access sign through some pre-work is going to be really important in relationship to breakout room 5's discussion.
I think it would be great if we started with Patrick's question, if you wouldn't mind asking it again, Patrick.
Okay, it's pretty simple-minded actually. So for the whole group, how do you see the themes that you identified relative to NSF's broader impacts, which are part of the grant evaluation criteria? And NSF's been putting a lot more emphasis on broader impacts. So that's kind of a message that will go out to the whole grant community.
So is your question, how does that get captured in broader impacts?
Oh, more like of all the things that you discussed, directly relevant to broader impacts, would anything that we're talking about here actually show up as positive, say in a grant proposal, or if there were infrastructure that was available that will enable more innovative things and broader impacts? It's a very broad question, actually. I'll let you run with it and see what you think.
Sure. And I think Kristen can chime in, and some of the other experts that were in our room, please feel free to turn your video or audio on and contribute. But I think, the broad answer is yes, absolutely. And I think one of the things that I know I've had lengthy conversations with Kristen about as well, sort of outside of this workshop, is really thinking about, if we have this opportunity and if we are sort of shifting our investment towards formalizing or sort of elevating the importance and the role of broader impacts in these proposals along, sort of basic research. Of course, there needs to be resources. I think we need to, where possible, be bringing in the appropriate scholars and experts and practitioners who can really elevate. We don't need to reinvent the wheel in a lot of cases. There's a broad body of literature and experts and people who do this, who do sort of broader impacts related work and innovate in that space, who I think don't yet have an active role in many of the broader impacts that are I think we had lots of examples of really creative, novel, individualized, yet sort of connected to broader concerns, sort of broader impacts activities that were being described in our breakout rooms. But I think from my perspective, and I'll let Kristen chime in here too, is, it's got to be funded, and we've got to have the experts, and we have to understand what it is we're trying to do, who we're trying to reach, and ways to evaluate our impact. So I think really thinking about how to move away from a highly distributed model of like every researcher trying to figure it out on their own, really trying to develop connections across researchers, across people who are expert communicators. We saw many of those TikTok people, for example. Can we be using this as an opportunity not only to inspire new ideas and new participation and new ways to connect, but critically bringing in new expertise to help us develop and deploy our broader impacts.
I'd like to just follow up with that just a little bit then. So you brought back something I've thought about actually a few years ago, and I probably should say this with great fear and trepidation about my career longevity, but wondering about, is this a sort of thing that maybe is conducive to a center, some sort of specialty group that this is what we do, specialize in, and maybe you could bring in other grantees as well as on a service basis? I'm not sure what the model would look like, but it seems like there are other models that NSF has used in other areas.
Pat, I'm glad you should ask. You've read our minds. And I think others have had this idea, and Kristen and I have been talking at length, along with Juliana and some others, around how to actually do that. Is there sort of a the STC is not it's an imperfect example, but is there a mechanism by which there could be this coordinated funded work where there's dedicated capacity building opportunities built in for researchers, for practitioners, for educators, right? There's this sort of community that's built, there's capacity building that's happening, there's access to these experts, to the social science expertise, to the range and breadth and depth of communication and social science expertise that are really needed to do this work well. So I think, of course, if there are others on NSF, we are in the act of mapping out said type of project, not really knowing where it could go or how well it would be received. But I think we would welcome any conversations or interest in that, because I think that idea of coordination is a critical one. Kristen.
Yeah, I would just add also one thing that came up in our discussion was from the end user perspective. So if you have teachers that want to connect with Antarctica as one particular audience, how do you make it as easy as possible for them also? And so, having that coordinated effort isn't just necessarily useful in terms of the science and the work and making sure that we're, doing really good outreach or communication or education work, but then also making it as easy as possible for, teachers or whatever audience to actually find what's happening and, make those connections. So I think it's really helpful both ways, thinking about that kind of a model. That's
what actually I think led to my original thought. I kind of put myself in a teacher's shoes, saying I'm planning my my entire year. I like to have things plannable, something that I can count on. I know when it can happen. I know what it is. I know how to prepare for it. I know who to go to help me out. Basically, I book something almost, and so yeah, I could see how this could really be helpful for the educator down out in the trenches who's juggling all kinds of other things too.
Yeah, I think of the model of a group like Skype a Scientist, where they're a central group that any teacher can contact to set up something, and there's a standardized process. So I know from my personal experience, the teachers that I've worked with have been through personal connections, which is a very inefficient way to reach out. I want to acknowledge
I see Gwen's actual hand up, so she's got a comment.
I just want, can I say something first, Gwen? We are in our break time, so if people do need to take a break, it'd be now until, what did we say, 1/2 the hour. So feel free to take a break while we keep this discussion going.
Great, I just wanted to mention that I think there is a model for the center that you're talking about, which is out of the Office of Advanced Cyber Infrastructure, the new Cyber Infrastructure Centers of Excellence. So these are pilot programs. There's a couple of them now. And I would encourage you to look at the Dear Colleague letters and the other ones and the recent ones that have been funded, because what these do is they bring together a set of experts around whether it's the full data lifecycle or working with cyber infrastructure professionals. But the goal is to bring together a group of experts who then can act as kind of consultants or helpers, but really the goal, and the experts can be distributed all over. You can have folks from different places, but really it's a place for someone to come to your group as a one-stop shop to say, hey, I want to do this. How do I do this? I have these challenges. And I think there's been some really effective things already coming out of some of the cyber infrastructure centers of excellence where, and I wouldn't call it glorified consulting. It's not that. It's much deeper than that. And I was really excited to hear about your thoughts around social science research in this area, because this is really changing the way people are going to do business and live their lives. So really great breakout session. Thank you for that. Enjoyed it.
Thank you. And I should thank all of the other folks we had contributing their ideas in Breakout 5. So thank you, Julia, Cole, and Juliana, for your awesome inputs. It was definitely a team effort. And we welcome, I know these discussions and the other sessions sort of spanned and touched on Breakout 5. And so I think this is true for the other breakouts, but please add to our Google Doc, which is sort of a running role of the scroll of our active conversation. So please, if you have ideas or needs or anything, that is of course a living document, and there's a lot of expertise on this call. So please add to that as you see fit. And Pat, we'll be emailing you soon. That's what you get.
Remember, I don't have any money.
I know, but you have lots of ideas, which are really valuable. So that's a different currency, and a valuable one at that. I don't know if we have there looks like there's a comment on YouTube. And there's a plus for Gwen's suggestion of the COE model. So if this piques folks' interest, Kirsten and I can put our email in the chat, and please let us know if you have interest in learning more, contributing ideas. So thank you for the opportunity for this to be inspiration and further food for thought. So
yeah, I think there's a fantastic report back, and I'll just emphasize from the PI side of things, or scientist who does some outreach, that there is a critical role for the scientists who are deep in the science to be a part of the outreach, but again, having it not being us all trying to reinvent the wheel with our varying levels of skill and communicating to whatever audiences we're trying to get in front of. I think it's just thinking more intentionally about that and making sure that we budget the time that's required to learn how to communicate and to do the communication, budget it into our proposals in the same way that we budget our time to achieve the rest of the project is critical.
Mm-hmm. Yeah, and I think, covering some of the things that surfaced, just to expand that, I know we're on break, is just really thinking about, we have a lot of artistic skill in our community, other skills. And so bringing those and incorporating those in the work, it is, I think, so important, and often it seems hard to justify, but is I think really critical. So as you're budgeting out your time, building in these artistic and innovative ways to communicate, whether that's using a internet connectivity or not, I think is really important for connecting new people and telling the story of Antarctic science. So I don't have anything else to add. Peter, I don't know if we just formally go to break now, or I'll make the executive decision that we will go to break now for those who have not, and come back at past. So thank you all, and we will see you in about 15 minutes.
He seems to want to be a Jay-Z type billionaire who famously said, "I'm not a businessman. I'm a businessman. Let me handle my business." Well,
Okay, well, we should bring it all back here. So hope everybody had a good break, and it was a really great discussion around all of the breakout rooms. I think it would be fair to continue any of that discussion we want to, and I'm just putting up this slide so that we know we have the next 45 minutes set aside to identify major themes, but also and especially gaps and what we need to do a little bit more work on. Sorry, I forgot to turn my video back on. So I think this is very much an open structure, open for questions and comments, but keeping in mind priorities, gaps, and additional work we need to do, missing perspectives. And certainly, I think all of us co-organizers can sort of help guide the discussion here. So I'll stop sharing, and yeah, I think it's just a great time to sort of process what we heard from all of these groups and think, again, keeping in mind the goals here to outline the science case for increased connectivity from a subsea cable to Antarctica, and also the science case for the observations that would be made with an instrumented cable.
Yeah, so I think in this, as you showed, we'll be addressing priorities, gaps, missing perspectives, and then the topics that we missed, we know we missed at least, and need further consideration. Who is not here, who should be involved in the future, and then what we need to do to follow up, you know, and I guess in the shorter term. So things we've missed. People want to volunteer. I can begin, but
I have an unpopular topic. This is Dan Wagster. So every once in a while, the NSF likes to reevaluate the number of people that need to be at McMurdo. And we've discussed a few times offshoring some positions to an established location in the United States. Most of those positions require a 100% reliable link to McMurdo, and that's always been the showstopper, but that could be one of the side benefits of this sort of cable.
And what sort of positions are those, Dan?
I don't want to call anybody out, but command and control. If we can build a monitoring system that can track where everyone is, where all the assets are, what's going on, flight schedules, departures from McMurdo, returns to McMurdo and such, controlling those activities from a stateside location could afford a stable, multi-year, highly trained staff of operators that do basically what MacOps and MacCenter currently do.
Well, let me, in the smart cable group, let me just say, I listed these, but we basically did not have hardly any contribution from the fields of biogeochemistry and ecosystems. And so, you know, they absolutely need to be brought into the mix for the ocean side. And then also, we did talk about adding, you know, more and different sensors, and that makes cyber infrastructure even more important, as we learned with OOI. You know, the smart cable concept appears simple because nominally there are only 3 sensors, and one presumes one could handle that data easily, but the complication came up with OOI when they have like 100 different sensors and dealing with that. So we need to keep that in mind. And then lastly, observing system simulation experiments really need to be done to better quantify the benefits of doing this. Others, please step up.
I have a question, Spat.
Yeah, go ahead.
Okay, so well, one of the things I'm wondering about, looking at kind of the practical side of the cable, is what the group one, if they have any kind of vision in terms of where things lie on the overall spectrum of easy to do, hard to do, things that are maybe more off the shelf right now versus things we have to do some R&D on to develop, because that will give a sense of where would we interject different kind of capabilities in the life of a telecom cable system development. Might also have something to do, might influence the timeline of the overall development effort, might even influence the desire to, well, let's slow start the telecom side to allow maybe some of the smart sensor things to catch up. I'm just kind of wondering if there was any discussion like that, or is that a gap that maybe needs to be addressed?
Well, I would say that we do need to continue talking with suppliers and finding out much more specifically what they can do. Derek online here indicated that there are gaps in our knowledge of what is possible and what has been done in the past. And I think all the suppliers have always said that technically they don't see any problem in how to do this. They just want money to do it, and a modest amount of time to implement it. So I think one of the follow-up tasks is to really meet one-on-one with suppliers to find out exactly where their technology stands and what's needed to do the kind of things we've talked about.
Okay, so
as I've said,
yeah,
yeah, go ahead.
Yeah, that kind of hits it. I guess where I'm going to some of this is like, if we're dependent on the private sector to kind of help move us along on this, what do they need in terms of incentive to help to get them to move to where we need to be? And then I guess the next question would be, well, so how do we invoke that incentive? Is that something that the government needs to do? Or would it happen on its own in the commercial sector? I mean, these are other kind of insights. It sounds like maybe we need to understand more about.
Yeah, well, I can say that, I mean, there are proposals under review at NSF to help push this technical development forward, and to the extent that process, well, we can't influence it. It's in progress, but steps are underway to make progress. And I mean, there is a wet demonstration project off Sicily also that's kind of doing things in parallel. But there could be more. That's definitely the case. Yeah.
Let's go to Alex for the next question, and then Doug.
Yeah, thanks, Peter. This kind of gets at Bruce's point about other, the biogeochemistry and ecosystems part of what we can, of science that we could answer. And I joined this, or decided to join this workshop when there was a ship actually doing marine surveys in the Amundsen-Scott River right by Bigelow Laboratory. And I thought, wow, wouldn't it have been great had there been some scientists on that ship as well to collect data in real time. And so I guess my question is, as the marine surveys are being conducted, how is that process for a cable conducted? And if so, a lot of the biogeochemistry and ecosystem part, a lot of the science could be accomplished during that marine survey phase of the cable. So I was inspired by the group 5, they were talking about pre-cable studies. I almost see this as a start point or a time zero point before the cable is installed for a lot of these other disciplines that may not be able to be monitored during the cable. So I'll stop and listen. Thanks.
Yeah, I could say that. I mean, you're right. There would have to be marine surveys done, and presumably some of the. I mean, it wouldn't be typical survey vessels. Probably it might be the supply ships going back and forth that do have the multi-beam mapping capability and so on, and also doing standard oceanographic work as well. So it would seem like one should be able to piggyback and probably, just as Doug was mentioning, one would want to do CTD, transects along this cable route every single year, so that's going to create its own time series, if you will, and one could start that in the pre-survey days even.
Yeah, I also think about sediment. You're talking about erosion of the cable, and taking a sediment core and looking at it, gives you a lot of perspective as what sort of depositional environment we're in.
Right, and that to some extent that's part of a standard cable route survey is sampling the sediment and its structural properties and so on. But again, since it's probably going to be done from a science vessel, then that could be expanded, I would think.
Derek, did you have a comment or a response to this?
Yeah, I just to give an overview of what a cable survey typically looks like. We're running side scan, sub bottom, multi-beam. As Bruce said, there's a seabed sampling component, so cores or grab samples. That would be in burial or horizontal drilling or areas. And then once you get past those kind of cable protection areas, they would switch over to a multi-beam alone survey in the deep areas. That whole time, we would also be doing CTDs because we need to know the sound velocity profile for the multi-beam and the other equipment. So adding to that is, and for example, if a commercial survey company were used, adding to that scope and having additional people on board to supply kind of a science support or perform additional science duties probably wouldn't be that hard. It would just potentially add time to the survey.
Great, thanks. Should we go to Doug?
Thanks. I'd like to get back to Derek's concern. I've got a comment and a question. The comment is that I think we can get to the end design of this cable infrastructure quicker if we pay attention to the history of other observatories, and especially the Ocean Observatories Initiative. And I'm going to put another plug in for Deb Kelly's talk in the plenary on lessons learned from the regional cable array. That's something that, and she offered, I think, in one of her chats, that we should have a workshop in which the lessons learned were more explicitly and detailed, disseminated to this group. So that's the comment. The question is for Patrick, what is your time frame? And by this I mean, it took 10 years from the first really significant science meeting for designing the regional cable array before the cable was deployed. Now I expect you don't have 10 years to wait for this. So what is your time frame?
That's a good question. And I don't really know that I know, other than it will take what it will take. We're doing a one-of-a-kind thing, I guess, kind of like OOI was. So there could be budgetary things in the future that I do or don't know about. I just know that right now seems to be a good time to bring this topic up because the political climate seems to be favorable to it. There's interest within NSF about this idea. We need to keep moving forward the technical feasibility, to get to the some sort of decision point to see, does it make sense to keep going forward or not? And I want to keep pressing on that as hard as I can. So I guess the answer is I'll press on this as hard as I can until I hit a brick wall, you know, at least from my perspective as a program office.
With regard to that, you know, when I think about the design, and we ran into this issue with the OOI, is that this has been a great meeting in everyone expressing what science can be done. You know, the pie in the sky kind of stuff. We could do this with it. We could have branching units. We could do underwater, under ice surveys and so forth. Depending on how much time you spend on that, you can develop incredibly expensive and complex plans, which will get you to a brick wall, which is one of the experiences, one of the lessons we learned. We hit several brick walls as we were developing the OOI, where NSF said, no, you can't do that. This is, you're going the wrong way. And then we had to step back, reduce the design, cut it down, focus more on particular science topics. So, you know, some specific science leadership right now and guidance from NSF, I think is really important for us to keep on up the right path to a relatively quick decision.
So it sounds like you're basically saying there needs to be some good tight coupling in terms of scope definition as we move forward, just so it stays within, you know, the rails more or less in terms of what's considered to be implementable or feasible. Okay,
yes.
Well, that's point well taken.
Oh, and then, by the way, the thing which was most restrictive, we had some great plans, and then we got slammed with the requirement that the operation and maintenance budget per year had to be a fixed amount. And that cut all our plans back by 50%. That one restriction just knocked off 50% of the science.
Sounds like more follow-on discussions about lessons learned on OII are definitely are warranted. Yeah.
I want to acknowledge the question that Eli Dart put in the YouTube chat about 10 minutes ago. What could we do that we are simply not contemplating today because we know it's not possible? And this is possibly going counter to the advice that Doug just provided, but it's an interesting question. Maybe we don't have a clear answer right now, but good to keep in mind. And I want to acknowledge that Laura is the next person with a hand up.
Hi, just this relates a little more to some of the earlier questions in this session, and it could relate some to the cable route considerations. But I mean, something I'm really concerned about, particularly, well, thinking about, you know, the cable we're thinking about from New Zealand to the Chathams, and it seems like it could be a big issue here. It sounds like there's a lot of strong currents and things like that. Are issues around, you know, coupling of the cable to the seabed. If you have inline sensing with SMART and DAS and things like that, if you have shimmying or twisting of the cable, that could heavily compromise, you know, your scientific observing capability. And I guess it would be really good to hear from maybe people like Derek or others who have some experience with these submarine cables. You know, how much they expect that to be a factor, and also can there be some things to mitigate this in terms of burying it? Could that help? Or in certain key portions, and also considering the routing, perhaps in the site surveys, kind of avoiding areas of really strong oceanographic currents. I don't know, it'd be really, it's just something we're concerned about here with our other initiative, and it'd be really good to hear because that could also influence prioritizing or not the discussions of branching units and so forth as well, that would allow external packages and more coupling to the seafloor.
So I guess I could jump in. Normal telecom cables, we performed the survey to try to avoid probably the most interesting areas of the ocean, right? We're trying to protect the cable as much as possible. So, you know, the cable type changes with depth as well. So in shallow, you'll have armored cables that, you know, are easily buried, provide a little bit more protection from abrasion, are a little bit heavier, so they're potentially less prone to strumming and things like that. And then as you go deeper, you get an unarmored cable. And to give you an idea of how big this cable is, it's probably about most suppliers, it's about 17 millimeters in diameter for the deepest ocean cable. So any kind of currents, any kind of suspension of that cable, it could be, you know, it could strum, it could abrade. We try to lay the cables in slack to conform the cable to the seabed in the deep waters. But depending on the size of the feature in the survey data, you could easily miss something that could suspend a cable slightly and cause that strumming nature. The other thing I think that needs to get taken into account for some of the DAS work, and other people can correct me, is just how the cable is manufactured. Cable length is not the same as fiber length in the cable. There's actually a certain amount of fiber slack within the cable. There's slack coiled in junction boxes and in the repeaters and the terminations and all. I think for some of what we're talking about, that probably needs to get taken into account as well, and can be. It just adds to the amount of work that needs to be done to document the cable structure and the cable design. Going to some of Doug's comments, I think a lot of the technology that we talked about in group 1 is available right now. A lot of it, the extra design work that would go into it would be the interfacing with the sensors or the instrumentation. Is it a wet mate? Is it something that can be, is it high reliability and long life that it can be integrated into the node or the branching unit or the repeater and deployed with it? Or is it something that an ROV has to deploy and plug in subsea, something like that? So a lot of these things need to be considered from a construction standpoint, but they need to be considered from an operations and maintenance and management standpoint too, to Doug's comment. And I think Deb brought up a good point yesterday where you don't want to constrict the design so much in your discussions with suppliers where they can't supply solutions as well, because the suppliers themselves may come up with very, very good solutions for some of the things that you want to measure or deploy or otherwise. I think one option that the suppliers are used to are front-end engineering design studies, where you supply them options and basic requirements and potentially let them come up with a design for the network and the equipment that gets deployed. You supply the instrumentation and the power requirements and the interface requirements, and you potentially see what they come up with. And those options, you can then do a cost-benefit analysis against the prioritized science elements that you want to do. You know, there's the straight telecoms, there's telecoms and smart repeaters, the telecoms, smart repeaters and branched localized observatories. You know, maybe there's some development of intermediate sensors, you know, but you could do a lot of that study in a front-end engineering design study program with suppliers.
Let me just comment that the Portuguese CAM system is preparing their RFP right at this moment and expect to issue it in next month or two. And the understanding is they will provide a condensed version of that for public consumption. So we'll be able to see the basic elements of an RFP going out and to see how they handle, you know, not overly restricting, but you know, getting what they want.
Let's go to William Wilcock.
Yeah, I just wanted to respond or follow on from Doug Luther's comments, and some of what I'm going to say has already been said, but I think that a lot of the challenges that the OOI had was that when the process was started, really nobody understood how much it would cost. And as the system got down scope, the budget stayed kind of the same. And a lot of the expense and complexity comes from installing secondary infrastructure, where you take a point on the seafloor and a cable and you want to sort of spread out your instruments. And there hasn't been much discussion of that, I don't think, at this meeting. So I think having both smart cables and compact sort of basically sensors deployed around a branching unit, I think can be done more cheaply. And I think a lot's been learned about what sensors are reliable and which ones aren't. So I think a lot of lessons can be learned from the OI. So I don't think we have to go down that route. And particularly, but people do have to worry about operations costs, I think, up front, because clearly that was a concern in OCE, which has constrained the whole of the OI.
Good. Let's see. Any comments from? I mean, we've talked more about the cable. How about from the other groups, glaciology and are there what have we missed there? And biology side on land and space.
I certainly will let others speak. I've been speaking plenty at this workshop. I would say most simply that making sure that we are abundantly clear that there is a tight linkage between observing the ocean near Antarctica to what is going on with the continental ice in Antarctica, the ice sheet. You know, the majority of the change we're seeing is that the ice shelves that are floating on the ocean, and it's from basal melt underneath the ice shelves. Understanding the ocean is key to understanding the future of Antarctica in a big way. There certainly are terrestrial processes, ice dynamic processes that are separate from ocean observations. But I think that's a really key point that we need to not forget and emphasize very clearly.
One thing that came to my mind was that as something that should be evolving in parallel with this effort is to pay attention to more the ice shelf aspects. Matthew very nicely put out ambitious pictures of cables above and below and AUVs, and I think you know, that work needs to proceed with the expectation that maybe, you know, in 5 or so years, a cable like this will be there to have the necessary data connectivity. But we've got to have these other things going in parallel, so when the cable does materialize, they can make use of it right away.
Yeah, let's hear from Matt.
Yeah, one thing that Matthew brought up on the first day that I think should be stressed for the glaciology component is how tied in we are to weather for logistics. And so any improvement in, say, a weather radar on Ross Island would hugely increase the efficiency of deep field logistics. So you're not boomeranging. So you know when you can land in McMurdo. Like, just anything to eke out fractional percents in efficiency for the glaciology community, at least the deep field glaciology community, that's a huge deal.
Yeah, I agree. Then for those aspects of the science that otherwise are completely disconnected from the opportunity that connectivity or cable observations brings, we are drastically impacted by poor weather forecasting right now and just bad weather, period. So if we can better forecast the bad weather and know when to sit it out, it saves a lot of operational costs as well, you know, knowing the expense of flying the LC-130s, that sort of thing.
Yeah, I'm glad you brought that up as well. I know that was part of discussions, but cost avoidance is clearly something that's important to NSF and the science community, and boomeranging is an issue, and anything that can be done to improve forecasting certainly has huge implications.
So are there steps in progress to get a weather radar down there?
Yes.
Is that what's needed?
It's been actually tested just before COVID hit. The Air Force lent a radar to be, and it was run for a season or part of a summer season. We just had a report on it at our weather workshop that we just held last week. There was also some scientific radar stuff that was done 2 years before that. We're just dipping our toes in this. There's more to be done. Not work that my particular group does, but others in our community is doing. So it's in progress. And if we're going to work with volumetric data and the forecasters, which are, by the way, another group that doesn't sit in McMurdo, there's been an effort to move them off as much as possible. They still has some forecast presence in McMurdo. The data's got to go back, and it's got to go back to Charleston, and they have to have it, and they have to have it now. They can't wait. So yes, that's why we need this, period. And that means, by the way, we need good comms all the way out to wherever the radar sits. And that was another challenge about figuring out where's the best place to put it. Right now, they put it out at Phoenix Airfield. We can still debate if that's a good choice, because I think good places to put it, there's no comms and power, and good places that there are comms and power may or may not be ideal weather observing. And that's being debated. But the point is, we need that.
Okay.
Well, and I'd like to point out that we've made great gains on shrinking the satellite gap. So probably what you guys are referring to is a period of time where the LCs would hit a period of 6 to 8 hours of a blackout period. We've shrunk that now down to about 2 to 3 hours. So a weather radar would give us that now casting within 2 hours. So it would give us a 24-hour picture of everything that's going in and around McMurdo. The reason we wanted it at Williams Field or Phoenix is that's where you see the fog formulation come in at windless bight, which is a huge problem for the LCs. Is you can't very accurately predict fog, but we're thinking that the dual pole X-band radar will be able to see that. So we're in the process. It's competing with other things, but the weather radar is a line item for our capital investment project, and we hope to have one within the next 1 to 3 years.
Just in time for the cable.
Gary, Pat just asked if you wouldn't mind explaining the satellite you reference is the weather imaging satellites and a gap in coverage around local noon at McMurdo.
Yes, so the direct readout stations at McMurdo, we're only able to pick up the older NOAA satellites. We did a service life extension program 2 years ago that got us the new receivers and the processing power to actually pick up the newer satellites, process that data, and give us that information. And the newer, Pat can probably explain this better than I can, but the newer satellites have a broader swath of coverage. So we pick them up earlier and we lose them later. So that effectively shrunk the gap. Did I explain that?
Yes, that was good. That was good. The only thing it's missing is that there will always be a gap.
Yeah.
Because the world has decided to only launch polar orbiter satellites at basically fixed equatorial cross times. And we are not big enough to influence the world to stop doing that, pretty much. So although this program's in a position where we could get some satellites that are on the fringe of fixed equatorial cross times, like we got, FY, 3E, which is a Chinese satellite, or some of the satellites might eventually drift out of their fixed equatorial cross times. There's always going to be a gap, and it's always, just because of where McMurdo is located and our time zone arrangements, always going to be in the middle of McMurdo's day, which is a havoc for operations.
And the satellites orbit, so we're not picking them up, every minute of every hour. We're picking them up at certain parts, certain times in different satellites as they come across. So what a weather satellite or what a weather radar does for us is it, rotates, we get that whatever's going to hit us within 2 hours, we see that coming. So.
Yep. Very good, Gary. That's perfect.
I know Pat's had his virtual hand up forever. It might be falling off by now, unless you didn't mean to have it up.
No, I actually intended to put it up, and now I think I forgot what I was going to ask.
Oh, sorry, we waited too long.
Or maybe it was a strategic wait. So
not at all. And I did want to flag that we're in our last about 10 minutes here of this section. Before we focus more on you, Pat, NSF is the next up.
Maybe we could talk about who isn't here. It seems, we do have representatives from Australia, New Zealand, but I think, and we should get representatives from Chile and Argentina, South Africa, spanning the whole globe, so to speak, around Antarctica. Liaison people, if you will, just to make sure that they're aware of what's going on. And as has been mentioned, is this the start of a Southern Ocean cable system, a network? So those countries should be involved. And then on the international ocean scene, at least, the Global Ocean Observing System ought to be involved, again, in a liaison capacity, probably. The UN Decade of Ocean Science for Sustainable Development, in one way or another, is a new international initiative where this could fit in. And I assume, within the Antarctic community, SCAR, I think is the term. I don't know if that organization has been formally briefed about this yet or not, but obviously they should be. And then in the US, I mean, we all know, NASA, NOAA, DOE, and DOD need to be involved, and NOAA, one really needs to turn the screws on NOAA to take a more active role, I think. That's my 2 bits on that topic. Other people who should be included?
South Korea and
who wasn't
Italy.
here?
South Korea and Italy in particular, because they're in our corner of the world, of Antarctica, sorry, that are potential partners. I don't know, Pat, you may want to, or Gary, you may want to comment from the NSF's angle about international partnering arrangements, but geographically they're next door. The other thing that came up point blank at our weather meeting when we met as a weather community, there was an expressed interest about that kind of connection being made. I don't know if there are others. I don't know the status of other international station arrangements in our corner. There are.
And John Cottle in the chat made a good point that COMNAP, the Council of Managers of National Antarctic Programs, is an essential structure for sharing this sort of information. And I was offered to give the opportunity to give a presentation to the U.S. component of the Scientific Committee on Antarctic Research. I may have missed the boat on that in organizing the workshop, missed an abstract deadline, but there will be more opportunities for sure to report back to that community.
And one other thought would be, and David and Garrett are perfectly tied in, is to make sure that all the research and education networks in the world are aware of this. And I know Géant is working in Europe already, and NordUNet is fully aware of this, but one would like to broaden the message out and make sure that they're aware that these kind of things are going on. Right, Clara, also.
Matt, I see your hand up.
Yeah, I just wanted to flag the international partnerships. I don't think any of the program managers that were at ICES in Korea in 2019 are here, but Peter Doran and I presented at an international Ross Sea sector how do we collaborate more workshop that had representatives from 5 different countries. And this is certainly something that would feed into that sort of partnership. We were all looking for new ways to collaborate across the countries with stations in the Ross Sea sector.
And I can't remember who put in the chat also the mention of the Ross Marine Protected Area. That's another element that we haven't discussed much at the workshop.
Does NOAA play a role in that?
I'll pass on that. I don't know.
Yeah. Okay. Any other thoughts on who should be here and isn't, or should be represented, or at least in a liaison mode, or other science groups?
This is where you answer Pat's question.
So I thought of a new one. So one of the folks I think might be missing are NASA. They have the long duration ballooning program at McMurdo, which when we get out of the COVID years and they get back into full op tempo, they'll launch 2. They hope to sometimes launch 3 payloads. They've got a data tether and monitor control and optical monitoring tether back to the U.S. and the Palestine balloon facility. Also other NASA science, kind of wondering, NASA's got this ground station there that was initially put in 1995 to pull down synthetic aperture radar data from RadarSat-1 that was supporting the Antarctic mapping mission. And it's since been kind of morphed into a general purpose tool that brings down data from science and international collaboration, science research satellites and polar orbits. High latitudes in the southern hemisphere are considered desirable for the space data guys, just because you can reduce the latency. Same reason why, that for our weather satellite observations, you can cut latency and data return, and that helps support a lot of different science objectives that depend on low latency. Also, it helps you technically because you don't have to store as much data on board the satellite. You can pull it down sooner. So, all those research satellites, I mean, they're sometimes not directly related to Antarctic science, but they are the broader kind of a science environment. And so this could have a role in supporting them. So wondering if maybe, NASA, SMD, getting them engaged.
So they are, Pat. So we did have multiple times throughout the week, Torsten Marcus, who's one of the leaders at NASA Cryosphere, has been on the call, and I've had some emails with Mark Harris, folks who are on the team for that ground station in McMurdo. So they're definitely aware. And I know Tom Newman, who works on the ISAT-2 satellite, also has been aware, maybe watching the live stream.
So we need to make sure the other parts of NASA know the long duration balloon folks aren't those folks. They're a very different group.
Yep.
And they don't talk to each other. So they, by the way, in addition to the things that they do weather forecasting at Willie. And so if they're out there in the field, and by the way, they want the same, that were part of that little pink line I had in our presentation, that little network. So that would be a great addition. By the way, Bruce, to answer your question on NOAA, I was just realizing that didn't get answered properly. The answer is no, right? NOAA basically has two roles in Antarctica, right? The clean air facility at South Pole and some estuary work on the peninsula. Otherwise, they don't have a role. And Pat and Gary, you're welcome to correct me if I'm wrong, but as far as I know, that's the biggest and only things they really do.
Oh, they've got 3 satellite ground stations, just like NASA does, that pulls down their data and for their mission that we all depend on for forecasting.
Right, but that came out in our breakout session when we talked about it. And I'm sorry, I'm forgetting the gentleman's name who was there because I'm not remembering it at the moment. Basically said wasn't going to change a lot of their needs and expectations.
Bill Munley.
Yes, correct. Thank you. Thank you for correcting me. Yes, that's right.
Yes, I've noticed that. That's true, but their unchanging needs and expectations tend to change with needs over time. So
right.
Bill Munley is on the call here. Bill Munley
good. I'm glad you're on. So I was like, he just mentioned there wasn't much change. So if there is going to be change there, then yes, there's a definite need. So
I wouldn't say that there definitely is. I would say that there's always a potential because things never stay the same. NOAA's also, as you know, Matt, NOAA is looking at these future satellite constellations and generations. Totally different architectures and how they do things. This could be, another input into that whole thing as well. So never know.
Agreed.
So I did talk to or email with an individual NOAA person on the peninsula. I can't remember his name, but he did indicate that NOAA did have interests around Antarctica and in the Ross Sea area from a management point of view. I know whether they actually do any real management
would be the marine protected zone, which I have to admit I threw a question in the chat about. Is there going to be a problem with the laying cable in a marine protected zone, which I assume there won't be, but it's something I'm sure that needs to get thought about, right?
It is done. I wouldn't say routinely, but when necessary.
Right. There was just a meeting held about that and a report put together about that, which I was very fortunate to be a part of and get to listen to that biological community, which it mostly is about all the issues that go into that marine protected zone. It's the biggest protected zone on the planet. So
I don't think it's an issue. You probably have some specific survey requirements to collect data for the regulatory and the permitting. Probably won't be allowed to bury a cable.
Yep.
But yeah, it's been done before.
Cool. Yeah, it's just a really big area. It's huge.
Yeah. I mean, that issue was flagged for me in conversations and organizing the workshop. As certainly there are many people who will like the idea of having observations in an MPA, and Ross, one of the biggest, one of the newest. There will also be parties that would not like that sort of observation.
Yeah. The people that put together the report was Cassandra Brooks and David Ainley. So, and then yes, there was no representation at that. That is correct, because I guess they're a regulatory agency unlike NSF, so therefore they have that interest there. That's correct. Thank you for reminding of that as well.
The one other comment I had was, and I think this may have been mentioned, NASA NOAA put up $40 million for a ground station in Svalbard to pay for a submarine cable to Svalbard to support a downlink station. So there is absolutely precedent for those kind of partnerships just based on satellite downlink issues. So it would seem like NSF should make those connections and see if one can get the same kind of deal.
Hey, this is Bill Munley. Y'all heard my name. Y'all have questions, I'm here.
Yeah, sorry, Bill, if I misportrayed anything that we talked about yesterday. Didn't wanted to make sure I portrayed it properly. So, okay,
that's fine. That's good.
So, Peter, we're at the 15-minute mark. Do we want to attempt the last question, which is we've sort of touched on much of it, is what needs to follow up right now or in the near term?
Yeah, I mean, I'm happy as well for this discussion to just sort of naturally slide into the next, what did we have, half an hour set aside to specifically target Pat. And if you're the only NSF representative, it's all on you here. But yeah, I think, as far as immediate things, I might highlight that I have a small crack team of early career researchers who are thinking about issues, particularly on that side of things, and a bit on DEI issues. So I'll continue to work for them, and I want to thank them for their help. So Melissa Diaz is on the call. My student, Julia Andreasen, who's taking notes mostly here, but is also helping with that. And Chloe Gustafson and Ryan Venturelli. So thanks for that. And we'll keep working on that. I think that is something immediately. There are sort of more conversations with voices who are not represented here, just in general on that side of representing everybody in the Antarctic science.
And Peter, in all, I just noticed in the chat window that Alan Pope noted that he's here as well and is happy to answer questions.
Great. So yeah, I mean, we are coming very close to the end of the workshop, and we intended for this, to be a moment to circle back in case we had not had a lot of interaction with NSF folks all along the way, and also maybe if either of you want to convey things that you've identified throughout the workshop that you'd like to hear more, or different ways of presenting the information, right? Like hard numbers versus being wishy-washy, or very clear science goals. And it's been great to have some of that feedback back all along the way already.
I mean, I think the most important part is that the breadth of the conversation, where there are numbers or defined, great. And when questions are wishy-washy or whatever, say that too.
You're breaking up. Sorry, Alan. You sort of broke up in the middle of that.
Oh.
Speaking of connectivity.
Sorry. Yeah, I got the internet is unstable message. I'll stop my video, see if that helps. Yeah, long story short, represent the full breadth. If it's not in the report, then it's going to be really hard to use it moving forwards.
Yeah, if I could maybe add to that just a little bit. If there are areas you feel like there's uncertainty and might be worthwhile follow up, I think that's probably worthwhile bringing out as well.
I have a question. When do you think NSF would be in a position to commission a engineering study or desktop study for the cable, and then also in parallel maybe a preliminary cable route survey, have one of the supply ships follow a tentative cable route? I don't know if that's practical this early, but and then also funding things like Aussies to help get the ball rolling. When do you see NSF being in a position to take those steps?
For some of that, I would say now, and I have authorization to move forward on a desktop study and a front-end engineering design. And I'm kind of under the gun to get something put in place by the 1st of August, maybe the end of this month. So I need to be working. I'll be getting some assistance from Defense Information Systems Agency to do that. This is right up their alley in terms of some things they do, and they have specialists that they can bring to bear. So I am going to have to be working on some input to that. So I'm interested in anything that I should know in terms of this group's wisdom that should go into the front-end engineering design in particular, that especially when it comes to the sensors, so that I can feed that into the study, the SOW for the study. I will be kind of cost constrained. So if I come in with a ton of good stuff to study, but I only have a half a ton worth of funding, I'm going to have to de-scope, which may mean that means I'll have to maybe do an additional follow-on. Doesn't mean that we won't address them, but getting a sense of the relative significance or priority and things that should be considered in the feed would be very helpful. And
it's
of course,
just something
that's a sooner than later kind of thing. That's probably outside the window of your formal workshop report too, unfortunately.
Do you anticipate DISA itself will form a group to do the studies, or do they go out put out an RFP for a contract and so on?
I probably shouldn't get into that level of details, but because government contracting, all that sort of stuff. But it's more or less a thing I can drop into. Let's put it that way.
Good.
And I would like to add too, also, that the Office of Advanced Cyber Infrastructure is a co-funder in that effort, 50-50 with Polar Programs. So there's a lot of support from OAC on exploring the feasibility of this. So from a cyber infrastructure end-to-end perspective, there's a lot of interest on this as well.
Excellent.
I have just a quick question or a comment, or maybe it's a risk. One item, it came up during one of the breakouts. Is the study going to include the terrestrial components to get the cable back to a cable station, and from a cable station back to a point of presence? Because that backhaul component could be a significant cost or risk depending on where the cable landing is selected.
My impression at this point from the discussions I've had is that we would have to include the cable landing station that's not in the Antarctic as part of it. And so we're going to look at the potential of 2 different landing sites, New Zealand and Australia. And so that backhaul component, at least getting to some sort of point of presence, I think that's where we would leave it. So that's where the whole NREN connection would start coming in. So where do we need to get in order just for us to interconnect with an NREN, a meet me, or some sort of interchange point? So that's, as I understand it, that's the way the scope would be at this point in time.
So things like at a cable station, maybe this is too much detail, at a cable station, would one include additional extra conduits for presumably slant drilling and so on for future cables, or going off to under the ice shelf and things of that nature?
Well, that would be the landing at McMurdo then, I would assume, right?
Yeah.
So for McMurdo, because of COVID and the timing of the study and all that, we can't do what would be expected in one of these studies, is to have an actual site survey for a cable landing in McMurdo. So it's all going to have to be done virtually. But we've got a lot of good site information. There's been a lot of good grant studies too that have been done on just what's out in the sound right offshore of McMurdo. People have mapped the all the debris and junk that the Navy has dumped there when they used to dispose of trash on the ice shelf, and so there's some reasonably good bathymetry. Probably not exactly what they would want. So we would still probably have to do a follow-up study for details. But I think there's stuff that's probably good enough now for feasibility evaluation and maybe cost evaluation. And of course, McMurdo has got a lot of infrastructure. Everything is very compact. The anticipation is that the ultimate SLTE probably would be in the new data center that we're building. And we're anticipating that probably to be finished by, sometime in late calendar year 2023 or maybe early calendar year 2024. There's an existing fiber optic cable plant that's being re-engineered on station. There's even suggested possible location for a landing. We've got a riprap, local mined stone riprap jetty for our saltwater intake that we use for the whole town. It's kind of an existing location. So there's a lot of ideas. We could probably accelerate what we would have to do on the McMurdo side for landing. So the idea of having at least additional openings for future boreholes or things like that. I mean, that could maybe be that could probably be baked into the desktop part of it.
Yeah.
But it'll all be, it'll be paper based at this point in time. So again, I guess if there's recommendations from the workshop of NSF, here's some things that we would really like for you to consider as you go forward with your desktop study and front engineering design. That would be useful to know. Whether or not I could do them all or not, I don't know, but definitely hearing from the workshop for what they think are important issues would be informative.
Okay. Excellent. Good. So a lot of these technical questions about smart capability and intermediate things between a smart repeater and a sensor blister and different hybrids would fall into this engineering study then?
I'm going to have to get into it in some way. I don't know how deep it would be. It might be more of a kind of a general assessment in terms of what the cost trades are. How does that influence the cost of the cable or risk to the cable? Especially if there's not something that's just right off the shelf, that would have to have some development work gone into it. I'm not sure how the response would be to that.
Okay.
The routing of the cable would be of interest. Anything that affects overall length or routing past geohazards that would be surfaced in a desktop study. I'm sure that they would want to do some sort of risk assessment on that.
And ice scour, I assume, will be covered.
That's part of it. We'd have to look at the ice scour risk. What regions of the route would be at maximum risk? What's known from the bathymetry, from what's available, which is, I think, quite a lot that Lamont has and other folks, where you could pick a safe route. And then I'm sure they would probably identify areas that would need closer examination with an actual marine study. At least that's my guess at this point in time.
Right.
So I just wanted to flag, I put in the chat a screenshot of an email that Torsten Marcus from NASA HQ just sent me to give their perspective, since there must have been somebody with burning ears on the live stream. So we got that update from them on how having remote calls with subject matter experts and being able to transfer large files would help them with respect to long duration balloons, that sort of thing. There's more than I was able to read here as well. I wanted to bring up a point that Wallace Chase actually mentioned 20 minutes ago. So about what are other mechanisms that on the science side we can continue to generate momentum on this opportunity outside of delivering the requested report. Because right, I mean, like it's been an exciting discussion today, and I think we all want to make sure that on the science side we keep talking about this, and if there are ways we can continue to solidify on what are the most important science aspects that we need to better scope to match with the engineering process, that would be useful to know, because I just don't know what mechanisms we might be able to do that through.
Peter, I have a comment to make. Within the RNE networking community, this is a topic of conversation that's been going on for a while, and we have an annual meeting where Patrick has presented 2 times now. So within that group, there's an active discussion going on, not only with those of us that are funded through the IRNC program, but also our international partners as well. If there are other kind of interest groups like that, we might be able to form kind of a network of interest groups. Because typically in those meetings, we talk mostly about network engineering, not so much about the science use cases, but blending those together, I think, would be helpful to keep the discussion going.
Yeah, I mean, I just wanted to add, and I don't want to speak for Alan, Kevin, Patrick, and others, that we spent a lot of time talking about engineering and installation. And I think one of the things NSF really needs from us, without which none of this matters, is we need to help tell the story of why this is really important. That the research is valuable, it will help improve the human condition. And I don't know if we got all the way there. It's a lot of fun to talk about horizontal bores and sensor packages, but that doesn't need 50 people brought together. And I hope that in follow-ups, we're down to not very much time left, that when we reach out to you, and we will reach out to you with a follow-up email and likely a survey, please try to help us understand why this would be transformational. As I joked when we were planning, the ideal story would be, if there were this cable and we could essentially eliminate data constraints between Antarctica, whichever locations, and the rest of the world, that the research we could do would help us with climate change, frankly. And it's an important agenda for the US government right now. And that's the kind of thing we need to be able to share. And maybe we won't quite save the planet with this cable, but the closer we can come, the better.
Maybe if we can jump to Matthew next. I just wanted to echo David's comment, because it's really critical that we make the strong science case for this. And we've got a lot of material to mine from the lightning talks, from the discussions, from the breakouts, notes throughout the workshop. So we have great resources there, and we very much encourage everyone to follow up afterwards to the extent that we can put it in your words. Many of you have been to the ice, what it's been like to be there, what some of the constraints are. So by all means, please reach out to your research groups and your colleagues. So if we're missing some of the nuggets that you think can really help tell the story, please do make sure that you share with us. So, Matthew, can I jump to you now?
Yeah, someone mentioned observing system simulation experiments in passing, but I think those are really a key place we on the science side can make some progress in the meantime with, I'm just thinking an experiment, a modeling experiment where you say what the improvement in global seismic tomography would be if we have this linear array of seismic components. And that seems to me something that's eminently doable in not a long time period, and just coming up with good experiments to test what the actual quantitatively test what the actual improvement would be in our science, I think and getting that documented in peer review publications is really important.
Yeah, let me step in. I would second that. I've said this before, but and I think Charlotte Rowe at Los Alamos is close to having simulations for global tomography, for instance, seismic. On the ocean side, though, I've encountered strong reluctance from the ocean modeling community because they see these OSSIs as being very complicated and labor-intensive activities and require real funding. So that's something that, you know, NSF can perhaps step up to encourage. Jumping around it slightly, as chair of JTF, I will make my whole community aware of this, and that includes suppliers and regulatory agencies. And I'm just about to send out an open letter to suppliers, the OTTs, Google, Facebook, regulatory associations around the world, telecom regulatory, as well as multilateral development banks to inform them about the smart cable activity. And given this workshop, I'll make it a little stronger statement about planning for Antarctica as well in that. So trying to reach a diverse audience. I saw Shar put her hand up. She's still.
I took it back down.
Okay.
But yeah, we did, we published a global prediction of the improvement for at the time, planned smart cable routes or proposed smart cable routes in 2017, just looking at ray coverage globally for what, you know, the current status quo where most stations, most certainly permanent stations, are on land, and then we added in smart sensors and showed the difference in ray coverage. Working right now collaboratively with folks at Sandia, we are redoing a global tomographic model with predicted ray paths to get model resolution, and we could certainly add this cable in to our predictions so that we could look and get some speculative idea as to how this particular cable could improve the tomographic coverage.
Good. Matthew?
Yeah, just a quick thing. As you were listing off your list of folks to notify, Bruce, I don't know if this is an appropriate question for you or for Pat or Gary or Alan. Does DoD know? I know that there is someone from the Guard, the Air National Guard, in the NSF office, but I wasn't sure if they were aware of the activity. Once again, another partner potentially.
They are aware in general. It was mainly just as an FYI and to broker a dialogue I have with somebody in the DoD CIO's office who's helping me with the mechanics of the desktop study. In terms of trying to explore them as a partner, it hasn't really been pursued. I might say that that's maybe a little bit above my pay grade. So, I mean, if the workshop wants to make that recommendation, I shouldn't stand in the way. However, you know, other folks would probably have to pick that up and work it.
Fair enough. Just a curiosity. Thank you.
We can share that information out of here. We didn't identify any specific mission, but Antarctica is in the AOR, as they say, of US Indo-PACOM, which is headquartered like 10 miles from.
Exactly. That was my thinking. Is
yeah, no, we let them know
right down the street.
Yeah, they're right down the street. So I don't think they identified a specific purpose, but they're interested, and we'll keep them aware.
Yeah, they're responsible even if they aren't heavily involved. Otherwise, the rest of the folks who do care are sitting in Schenectady, New York, pretty much, right at the.
Well, actually, yeah, if I could interject on that. So if you are talking Indo-PACOM, we do have the Joint Task Force, Support Force Antarctica, which are supposedly the official points of contact for management of DoD, you know, tactical support for the program. So just make sure there's no left hand and right hand things going on. Joint Task Force is actually part of Indo-PACOM, although they rely on PAC-AF a lot for staff. So there could be some people not getting the memo, or they didn't get the email or something. So just keep that in mind, David.
Great
None of us
advice.
organizations like that.
Yeah.
Parts of DoD and DISA are interested in this technology, at least being applied elsewhere to improve cable protection and improve the reliability of cables in general, and for instance in the Arctic Ocean. So they may be just watching this develop with the thinking that it could help elsewhere, perhaps in the world.
Well, we have.
Would it be Doug mentioned that one of the lessons learned was to early on start basically a science group project office or whatever that could quickly, sooner rather than later, provide the science advice and so on. Is it when would that be appropriate to set up something a little more formal than a workshop organizing committee? To Patrick.
I'm not sure I know how to answer that because I live in kind of a different part of NSF. I'm sitting here thinking that this sounds a lot like the formative stages to an MREFC project, where there's all these things that have to happen kind of either on regular grant funds, or I don't know, I guess maybe you can actually get a targeted proposal funded for early development work. I'm not really all that familiar with how it works. I just know that something happens formally when you go through these kind of embryonic concept development stages. And maybe for those of you who are old-time experienced grantees, or for Derek OOI, talk to your program managers about how that works, and are there, to see if there's some models there that could be followed. And that's about all I could.
OOI started with actually NOPP funding probably about 5 years before they actually committed to an MREFC. So
okay. So I guess the obvious answer is funding support has to come from someplace to formally support a group, and whether or not it's institutions offering this up on their own, or or there's some sort of proposal issued to NSF, I guess, for some sort of planning grant, which I guess that's how it would work. I'm a little getting outside of my rice bowl in that area.
We just actually had sorry. We just had a panel for the movement of one of our arrays, the Pioneer Array, which worked out fairly well, where it was a week-long panel and workshop that defined the science of the new requirements of the new location using an interdisciplinary panel that were all volunteers, about 35, 40 people. And then we defined the infrastructure required to address that science and those science questions. So that might be a good initial kickoff to set some baseline, requirements that could form a desktop study or a feed or something like that. But Bob Houtman and Lisa Clow were the NSF people behind that, so they might be a good contact.
Well, Lisa knows about the workshop. Yeah, but
yeah.
I don't know what Alan, if you're still on and working, I see you're online. You have anything to add to this?
Doesn't flake out on me again. No, I don't have a ton to add. I think learning from past experience would be good. My immediate thought, yeah, okay.
I think Gwen mentioned something about AGU meetings, having something. I think it's too late to get any session set up for AGU or ocean sciences, but I'm betting that one could have a town hall or something like that, and ocean science will be here in Hawaii next February. So
Come on over.
do polar science in Hawaii.
Well, we've done polar construction in Hawaii, so why not?
Yeah, I think an AGU town hall is a great idea to solicit another wide, across the science disciplines, cast a wide net.
I think NSF needs to be aware that maybe this is just a continuing problem, but people are getting burned out to some extent with all these planning exercises, and I don't know if the number of workshops has increased over the years or not, but it's and without funding basically, to do a lot of this stuff, and so anyway, just an observation.
Well, I'm sure as everyone who's reading the papers and stuff, we're on the cusp of possibly some major transformative changes in NSF. That the NSF for the Future Act was just passed by the House. The Senate's passed its incarnation previously, which I can't remember the title because it changed. Yeah. And plus the president's budget has a significant increase. So there's a lot of changes going on. We're changing OPP director here in about a month. An incumbent director, Kelly Faulkner, is going on detail to the State Department, and Dr. Roberta Martinelli is coming in as the new, at least an interim director, as I understand it. Lots of change. With change comes opportunity, maybe. So that's something to also consider.
Okay.
Patrick, there is one other mechanism I'm aware of, which is to form a working group within your advisory committee for polar programs and turn them loose on this as well.
That's true. Well, there's supposed to be a joint advisory committee session coming up between polar programs and SEIS, isn't
Awesome.
there?
Perfect.
I think later on this year. You were on the SEIS advisory committee, right? Are you still on, or did you rotate off, or?
I chaired the advisory council for cyber infrastructure. I rotated off a year ago, but we do have an ongoing working group working on cyber infrastructure professionals. But that's a great mechanism because all the folks on the committee are very well connected in the community and have lots of ways to reach out. So might be a topic of a working group through there, or a joint working group with SEIS.
Okay, I think that's something that Alan and I could take internally and kick the tires on.
Well, we are in the last 15 minutes that we have set aside here, and that means we're at the end of what we scheduled for grilling Pat and Alan at NSF, and it's been really, really helpful to have this discussion. I hope others agree. So I think we can move towards closing, talk a little bit about plans and just for closing out today and moving forward to get the rapid preliminary report out by early August, hopefully, and possibly a little bit earlier if it could be of any more help to Pat, and then a full report hopefully by early September. So I think the first thing that was really useful at the end of yesterday is, again, if everybody who's on the call here, before you start disappearing, you could go to this end of day survey that we have. And give us any feedback about what we've missed, especially in light of the last conversations we've been having here. What have we missed? Who should we contact? Contact information is super helpful so that we don't have to go do any extra digging. And feel free, any of the other co-organizers, to jump in here on details. But moving forward, that essential links document is still going to be useful. I think we can keep working with the resources that we've populated into the folders that we used today. So I'm just want to make sure I can find that link, and if somebody else has it more immediately on hand, let's see, I think I found it. We'll paste it into the chat here to make sure everybody has it. But of course, we'll be in touch by email to draft what we need to going forward, and also particularly have any extra conversations we need to have as soon as possible. So do any other co-organizers have thoughts on that before we officially close the workshop?
I think I just want to thank everybody, and again, thank you for generously sharing at least 12 hours of your time, most of you over the past 3 days. And again, a plea for ideas, including responding to Eli Dart's question imported from YouTube land about what are the things we haven't even thought of that this might enable, and of course, you know, the impacts of the science, that not just what you could do today, but what you could do tomorrow based on what you think might happen in your field. Oh yeah, and don't forget climate change. Did I mention that?
That's right. I mean, Antarctica is a critical place to keep track of as we continue to move into a warming world. Hopefully we choose to move into a slightly less warming world as soon as possible. But yeah, I've put up this final slide here again. Yeah, thanks for giving us your focused time over the last 3 days, and authorizing us to spam you a little bit moving forward, asking for contacts, thoughts, feedback on drafts of reports if we need. I just wanted to highlight that we did have more than 50 people on each day of the workshop for almost the entire time, which is great, and on the order of 20 to 30 people watching the live stream. So it's really great to have that attention. And again, days 1 and 3 are already up online as soon as we're done here. We're going to keep the recordings from day 2 to use internally, and so that we can keep those frank discussions to get them into the report. And I will highlight that the most remote participation, we're all participating remotely, and I appreciate that we're all still dealing with the numerous uncertainties that the last year plus has brought. So I hope everybody is still doing well and not too burned out after the workshop. Thanks to the South Pole team that tuned in. I thought that was a really nice, refreshing conversation and a good way to break up the day yesterday. So on behalf of the organizing committee, thanks again, and thank you so much to the National Science Foundation for supporting the workshop. Happy to stick
Thanks,
around.
everyone.
Happy to stick around for a few more minutes for chatter, and if anybody else has comments, go for it.
I have a comment, which is to thank you, Peter, for the incredible leadership and immense amount of effort that you put into guiding and leading and pulling this all together. I know you had a team behind you, but you really led the charge. So I know it was interacting with new communities and new perspectives and learning a whole lot along the way. So thank you for an incredible amount of effort with not a lot of lead time. It's been really great to work alongside you. But
well,
you
thanks,
were critical to pulling this off. So I think a round of applause for Peter.
Oh, thanks. No, I really appreciated getting to know the Hawaii team as well. It's been a really
wonderful to see the younger generation taking over.
You don't just want us to do the work, do you? No, it's been really a lot of great learning. I still have many acronyms to figure out, but that's what
yes, and I guess that is a huge thanks to the Hawaii team, because they have been up at very, very early hours of the day on a weekly basis to talk about these things, and so they've been very patient with us as we've learned new terms and communities. So also a huge shout out to the contingent from the University of Hawaii. It's been amazing.
I want to echo all of that. And one of the things that's interesting, so I want to note that although Peter, Heidi, and I are all part of the University of Minnesota, we didn't meet. I still haven't met Heidi in person. Peter and I didn't meet in person until about a month ago. We happen to be sitting in the same conference room on other sides. It feels kind of ridiculous, to be honest. We're in this 40 by 60 room on opposite ends of things. But I want to thank all the organizers. It's been a pleasure to work with you, and most importantly, all the participants and those from NSF. So we really appreciate, you're the ones that made this possible and drove it. We will certainly take all of your input to heart, and we very much look forward to your contributions going forward and into the report. And if we need help with that, we will certainly reach out broadly, and please volunteer if you want to play a role in follow-on activities. So I want to add my thanks to all.
Yeah, I'd just like to add my thanks to everyone too. I thought you guys have done a stellar job, especially under the time constraints you were given to do this. I think it was just outstanding. A lot of great discussion. We've had some like even new things that surfaced out of this, other than the original topics, which I think are wonderful, especially Group 5. So that was really great. And so I hope this is just the beginning. Not well, we're concluding the workshop and that's it. I hope this is just the start of a long journey. So I'm looking forward to what happens next. And thank you all. And it's great to see the NRIN nerds team up with the domain scientists. That's been a long goal, I think, of some of us in NSF to see that happen. So I'd like to see more of that keep happening too.
Hey, so are we on? I know Monday is a holiday, but for workshop team, are we? We probably should not let the grass grow.
Yes, I think so. I don't know if you can guarantee that you'll have both Heidi and me, because it being a holiday means that we don't have childcare. So one or the other.
I'm not thinking about Monday. But,
oh no. Okay.
No, I wasn't.
The next generation, the end user of the cable can participate in the meeting as well and provide her 2 cents.
I was just trying to remember, but I do think Peter had more hair when I met him at the first meeting.
Oh
no. It was all a lie that made me bald. Yeah.
And turned my hair white.
Yeah. That's right. Doug really stuck it out. Yeah. Okay. Well, maybe on Tuesday morning, do you want to get together?
Let's coordinate by email.
Yeah. Okay. Good. Okay.
We can't wait to get back together again. We just can't wait to meet again.
More Zoom. Thank you so much. And thank you to Jack for all your help with the AV.
Yeah, absolutely, Jack. Thanks.
Yeah,
Yes, thank you very much, Jack. You're fantastic.
Yeah, the logistics were, I think maybe flawless.
Flawless.
Besides a few reversed background.
User error.
The IT guy did great. Painless.
Yeah. Having all the documents in one Google folder really helped, I think.
The whole, I mean, I think the whole Zoom, Google,
right,
YouTube, other than I didn't learn Jamboards.
Right.
And I hardly use Twitch at all.
Yeah, next meeting we're going to have in Twitch, David. Get ready. We'll start having our meetings in Twitch.
Yeah.
We all have to upload that.
Well, I have to get off. I have a monthly phone call with DoD people about smart cables coming up in a few minutes. So.
Okay, I'm going to drop off.
See you later.
I'll go play president.
Thanks, everybody. You all.
Have a great holiday weekend.
Thanks, everybody. Take care.
Bye, everyone. Great show. Great workshop.
Thanks, Pat.
Thanks, Pat.